Hi guys, very good morning everyone. Welcome to the Maha Marathon class once again, and this is the control systems part number 2. Yesterday morning from 10 a.m. nearly going up to 3 p.m. You had the control system part 1, and we three, me, Ashu Jhangra sir and Farin sir, are combinedly covering up this subject so as to cover broader variety, so as to give you more range of techniques of solving the questions. Very good morning everyone. Quickly keep joining the session and quickly update all your friends that the session is live. Do not forget to share the session all across your WhatsApp and Telegram group so that students can join quickly. Chalo. Right, today first of all I'm going to start with the root locus. Yes, good morning, very good morning everyone. Very good morning everyone. Chalo, let's get started guys. Let's get moving ahead. Okay, students are again very slow in joining the class right now, but yeah, let's just begin up. Let's just begin up the classes. All right. Chalo. Aptitude marathon you are talking about, Yashwant? All right. Okay, guys. So, this is the brief introduction about me. You already know. Let's get started with the class directly. As you know, Maha marathons are coming up live for you every day at the 10 a.m. Yes. Every day at the 10 a.m. the Maha marathons, the entire team of ECEE and computer science ready for you to cover up your entire syllabus. It's not, you have seen, not one subject, multiple, means all subjects actually going on. And after technical rounds, the other subjects of aptitude and maths will also come up. And to all my dear students, let me give you the hint regarding to the aptitude also, that yes, that coming soon, aptitude most likely, chalo, I'll tell you in some time. I'll tell you in some time what is the date that we are deciding for aptitude. I'll tell you in some time, just stay for it, okay? I'll tell you in some time what is the most likely date we are deciding for the aptitude complete marathon, 15 marks, okay? But before that, let me give you an update that on the BYJU'S exam prep, a free mega workshop to be conducted to convert yourself from beginner to topper. Abhinav sir is going to speak about 7 success mantra, and he is MTech from IIT Delhi, more than 11 years of experience. Join him live next Sunday at the 12:30 p.m. 15th of January. And also guys, this Sunday, that is just the tomorrow at 12 p.m. you have the scholarship test, which can help you in getting up to 90% scholarship for all the GATE preparation programs by BYJU'S exam prep. All right. Chalo. So guys, quickly let's get started with the root locus. Do share the session to all your friends. Just a moment. Okay. Chalo. Good morning all. Root locus. Root locus, where we are going to talk about the locus, the sketch of the roots of characteristic equation of the system when the gain parameter k is varied normally from 0 to infinity, but it could be also varied for the negative values of k, and such a root locus will be known as the complementary root locus, also known as the inverse root locus. I will cover that as well. And when you swap the values of k from minus infinity to infinity, that is the root locus plus complementary root locus, swapping the k for all values, we generally call it as the root loci as well. And then there can be root contour cases when some other parameter or even multiple parameters are varied. These are the different cases that normally comes under the root locus. Let us first get started with this, and step by step I will introduce with directly, indirectly some problems. I will introduce the other cases as well. You are going to feel that. Okay, but to sketch the root locus, let's have a quick review. As you know, this is the revision class. We are not going into any derivation, but yeah, what are the quick rules? What are the quick rules that you must necessarily know before moving ahead. Okay, so important points to note about the root locus, because we are going to talk about the sketch, the locus of the roots of characteristic equation itself. So any point lying on the root locus, any point lying on the root locus must always satisfy the characteristic equation, because the diagram has come up from the roots of characteristic equation only. So what is the characteristic equation? We all know 1 plus GSHS equal to 0. Okay, this 1 plus GSHS equal to 0 simply gives you that GSHS would be the -1, and that is why its magnitude will be 1, and -1 is a negative real number, will be lying on the negative x-axis. So its phase, when you calculate, will be plus or minus 180 degree according to anti-clockwise or clockwise, or any odd multiple of 180 degree. 2k plus 1 represents odd multiple. So 180 or any odd multiple of 180 degree, right? And root locus is always going to be symmetric with respect to real axis, because if there are complex roots, they are conjugate in nature. If there are the complex roots, they are conjugate in nature, because the equations that will be there in front of you, okay, they'll all be having real coefficients, and that is why if there is any complex root, it will be conjugate in nature. If there is x plus jy above, there will be x minus jy below. Systematic procedure. Okay, before I take up the first problem, as I told you, we'll talk about the procedure. So what is the systematic procedure for sketching the root locus? Number 1. Okay, let's talk about the number of branches. Let's talk about the number of branches. Good morning, all keep joining. Okay, now number of branches. The number of branches of any root locus is equal to order of the characteristic equation. It depends how many roots you have. For every root we have one branch in short. And how many roots of characteristic equation? It is the order of the characteristic equation. In short, it is also given by the max of p comma z. Now sir, what is p and z? What is p and z? I'll write down here. P will be known as the quantity, number of open loop poles. Number of open loop poles. Sir, what are open loop poles? Poles of the open loop transfer function. Z is the number of open loop zeros. The zeros, the number of zeros of the open loop transfer function. Right. Root locus will be starting from the open loop poles for k equal to 0, and root locus will end either at the open loop zeros or at the infinity. Normally, first we are just assuming that p greater than z. Okay, sometimes the p can be less than z as well. There is a different story, but first let us get started with that itself only. The root locus will start from the open loop pole. The root locus will end either at the open loop zeros or at the infinity if there are less open loop zeros, right? But I'm telling you again, if there are less open loop poles, then the open loop zero story can be different. अभी पहले हम normally मान के चलते हैं. What I've just assumed is p greater than z. Then always for higher values of k, quick revision, okay? The root locus branches will be approximated by asymptotic lines, because wherever, I'm telling you, wherever the number of poles and number of zeros are not equal. If they are equal in number, suppose there are 2 poles and 2 zeros, 2 root locus branch will start and terminate on the 2 zeros. But suppose there are the 3 poles and there is only the 1 zero, so there will be one branch terminating at infinity, rest 2 will go to the one branch terminating at the open loop zero, rest will go to the infinity. And if the branch, that is red, going to the infinity, we need to define its direction. We will approximate the branches going towards the infinity by asymptotes. Okay, we'll be approximating the branch which are going towards the asymptote. So how many branches are going towards asymptote? How many branches are going towards infinity? Actually, it is given by the difference between these two. Okay, and what is the difference between these two? It is the p minus z. It is given by p minus z. So first of all, guys, what is the number of asymptotes? Very logically in the mind, remember that it is p minus z. Okay, jitne bhi zeros less honge, that many branches are going towards infinity. Okay, then what is the angle of asymptotes with the real axis? All these equations are derived by the characteristic equation method only. These two criteria are helpful in deriving various steps of the root locus, but right now I'm writing the formula. The angle of asymptotes with the real axis is given by the formula 2k plus 1 by n into 180 degree. Okay, this will change for complementary root locus, but abhi root locus ki baat kar rahe hain. So 2k plus 1 by 1 into it's like odd multiple. 2k plus 1 is a odd number, odd multiple of 180 degree by n. Okay, 180 degree by n. Say for example, if n is equal to 1. Now, when you have only one asymptote, that will always be at 180 degrees. So it will not be that relevant to draw the asymptote. Question se samjhaunga. But yeah, if n is equal to 1, okay, how many asymptotes angle? Depending on the value of n. Okay, the number of angles will also be equal to the number of asymptotes. So theta kitna ho jayega yahan pe? It will be only 180 degree. Right? If I take n is equal to 2, then I will have the theta, which is the odd multiple of which is the odd multiple of 180 by 2. That means odd multiple of 90 degree. And how many angles you need? Only 2 angles you need. The first odd multiple is 90, second odd multiple is 270 degree. 90 into 1, 90 into 3, odd multiples ke form mein. Right. If I want to talk about the n equal to 3, if I want to talk about the n equal to 3, then there will be the odd multiple of 180 by 3. Right. Odd multiples of 60. So 60 into 1, odd multiples only. 60 into 3, 60 into 5. These are the 3 angles. For 3 asymptotes, there will be the 3 angles. Right. Suppose n is equal to 4. So what is going to be the theta? So that will be given by the 2k plus 1, 180 divided by the 4. And that is given by what formula? 45 degree. Odd multiple of 45 degree. So 45 degree into 1, into 3, 45 into 5, and 45 into 7 next. These will be the 4 angles. And these are most commonly the cases, whether it's a sketching problem or analysis problem of root locus. For n equal to 2, 3, 4, these are the most common cases that can be encountered in front of you. Okay. Then these asymptotes intersect on the real axis. The intersection of the asymptotes on the real axis is given by the formula of centroid, and centroid is given by, I'll write down here, wo hidden hai. I'll write down here, x is given by the formula summation of all the location of poles minus summation of zeros is divided by the p minus z, is divided by p minus z, right? Next, breakaway points. Breakaway points. Between two open loop poles, there will be a point, okay, where the root locus breaks away. Now, what is that point? What is the significance? I will explain you with the example only. Abhi keval formula review kar lete hain. What you have to do to calculate the breakaway point? It will not only be breakaway, it could be break in also. It can be break in also. Dono bataunga. Okay, first of all, solve the equation dk by ds equal to 0. Write down k as a function of s. From where? From the characteristic equation. Very, very good morning, everyone. From the characteristic equation, first of all, you will write down k as some function of s, then differentiate with respect to it, put it equal to 0, right? And then not every solution of dk by ds equal to 0 will be a breakaway point. For it to be a breakaway point, it must lie on the root locus. What is the condition for a point lying on the root locus? Mod GSHS equal to 1, angle GSHS equal to 180 degree. That is one criteria. If it is a real root, very simply you can verify from this point also. If it is the real root, what is the existence of the root locus on real axis? This is the important point, especially when MCQ questions will come. Many of the MCQ questions, options can be just nullified and options can be eliminated by this particular point as well. That root locus will exist on the section of real axis if the total number of poles and zeros towards the right, total number of poles and zeros towards the right of that section is an odd number. Total number of poles and zeros towards the right is an odd number. Is an odd number. Is an odd number. Okay. Now, when will the root locus intersect with imaginary axis, for which you can use the Routh-Hurwitz criteria? If required, we will use the Routh-Hurwitz criteria there. Right. Angle of asymptotes, angle of departure and angle of arrival. Let us take a relevant problem where this angle is required and then I will explain you. Okay. Right now, isko chhod dete hain. Right. Angle of departure 180 minus 5p minus 5z. Angle of... Sorry, typo error. This is not required. Okay, and angle of arrival 180 minus 5z minus 5p, right? What is this? I'll explain you with the problem, then only you'll understand. This is a very good method of solving the angle of departure and arrival. Now, let's start with the question actually. Let us start with the question. But I think, dear students, you are, this time, it's cold weather and I think colleges are also on, whatever. But students this time are tired for the marathon. I think we'll stop, na? What is this, guys? Yeah, every day the attendance goes down. And we are here since morning covering up the entire day, but the students' motivation looks to be very much down. The students' motivation look to be very much down. That is not promising. What is this 46, huh? Chalo. Nahi padna, mat padho, no problem. Come here. Unity feedback system, unity feedback control system has GS equal to K S plus 2 divided by the SS plus 1. K S plus 2 is divided by the SS plus 1. Sketch the root locus of the system. sketch the root locus of the system. Okay, then we will look into the next part. इसको छोड़ देते हैं अभी. Then we'll look into the next part. First, let us start with the root locus of the system. Let us start by sketching the root locus of the system. Sketch the root locus of the system. Chalo, let's begin up then. Okay, let us begin up then. One by one. Now, guys, just keep focusing. Ks plus 2 is divided by Ss plus 1. Okay, now what are the open loop poles? What are the open loop poles? The open loop poles are at 0 and -1. How many of them? There are 2 open loop poles. What are the open loop zeros? Open loop zeros is at -2. There is only one open loop zero, that is at the -2. Right? These are the basic parameters. Now, of course, when you write down the characteristic equation also, you'll understand it's going to be a second order characteristic equation, and hence there will be 2 branches. Hence there will be the 2 branches. So as I told you, guys, these are just formality steps. For one problem, let us write down the number of branches will be maximum of 2, 1. That is going to be 2. The root locus starts from where? Very clearly, the value of P is greater than Z. The value of P is greater than Z. Okay, so root locus will have 2 branches, both starting from the open loop poles, and it has 2 branches which will be ending. One of them will be ending at -2 and another one towards infinity. Another one towards the infinity. When the zeros are less than poles, okay, you need the branches moving towards infinity. And for the branch that is moving towards infinity, you need what? You need the asymptote. You need the asymptote. How many asymptotes? How many asymptotes? There will be one asymptote. Okay, there will be one asymptote. At what angle? For one asymptote, angle is 180 degree. Already we have calculated. Let's repeat that, because the theta depends only on number of asymptotes, not on the location of poles and zeros. What about the centroid? Centroid, x is equal to summation of poles. Although I told you, whenever there is a one asymptote, for the objective question especially, you don't require this asymptote calculation. You know 180 की तरफ जाना है, but still let me complete the calculation once. So summation of poles minus summation of zeros divided by P minus Z. Okay, and that is equal to 1. That is equal to 1. Coming to the next important calculation. Coming to the next important calculation, and that is the breakaway points. Okay. For breakaway points, let me first write down the characteristic equation, because I want the value of K as a function of S. So 1 plus K S plus 2 divided by S S plus 1 being equal to 0. So what should be the value of K, sir? It is going to be minus of S square plus S upon the S plus 2. Minus of S square plus S is divided by the S plus 2, right? So what is going to be the dk by ds? What should be the value of the dk by ds? Tell me. What should be the value of dk by ds? Minus S plus 2 whole square. S plus 2 in the numerator constant, differentiation of numerator 2s plus 1 minus S square plus 1 constant, differentiation of S plus 2, and we have to put dk by ds equal to the 0. Okay, dk by ds equal to 0. Numerator को solve करेंगे तो I have 2s square plus s plus 4s, that is 5s plus 2 minus s square minus s being equal to 0. So s square plus 4s plus 2 equal to 0. So what should be the s? Minus 4 plus minus root over b square minus 4ac divided by 2a. So s will be minus 2 plus minus under root 8, 2 root 2, 2 cancel kiya. Minus 2 plus minus root 2. And I also told you that every solution of dk by ds may not be a breakaway point. For it to be a breakaway point, it must lie on the root locus. So what is the existence of root locus on the real axis? How to check that? Let us apply. I told you that is important for MCQ questions also later on. Okay, so what is the existence of root locus? अब इनमें से कौन सा valid है या नहीं वो बताता हूं मैं. Right. Next step, let me write down. about the existence of the root locus, about the existence of the root locus on the real axis. ठीक है, about the existence of the root locus on the real axis, about the existence of the root locus on what, on the real axis. तो देखोगे यहाँ पे आप, this is an important step to understood. Let us draw that once. Now we have the total poles and zeros. Let me draw those poles and zeros. We have a pole at origin, we have a pole at -1, and we have a 0 at the -2. Right? When will the root locus exist on the real axis? Okay. Hi, namaste Dibyajit. I'm good. How are you? देखो यहाँ पे, the root locus will exist on the section of real axis for which the total number of poles and zeros. You can also call it as forward poles and zeros. आप कहीं पे भी हो जाओ. Suppose you are here. Look at the forward poles and zeros, dear. Look at the forward poles and zeros. How many forward poles and zeros? 1, 2, 3. And that forward poles and zeros, if it is an odd number, yes, the root locus will exist there. Yes, the root locus has to exist here. Okay. But if I start from here, suppose I'm sitting somewhere here, and then if I count the forward poles and zeros, total poles as well as zeros, this is 2. This is the even number. This is 2. This is the even number. Right. Here, if I go and count the forward poles and zeros, then if I count the forward poles and zeros, right, this is 1. So 1 is an odd number. Wherever it is odd number, the root locus will exist on that section. Right. If I go and look here, how many forward poles and zeros? Nil. 0. Okay. That is equal to the 0. So that is counted in the even case. Done. So where will the root locus exist? I have indicated here using this pink line. Okay. Now, do I need the RH step here? चलो एक बार वो भी मैं दिखा देता हूं because it is the first problems. Intersection of the root locus with the j omega axis. So once again, if I want to write down the characteristic equation, 1 plus k s plus 2 is divided by the s plus 1 should be equal to 0. So I have s square plus s 1 plus k plus 2k equal to 0. And since this is a regular root locus case, k greater than 0, right, k is positive. So dear, if k is positive, 1 plus k is 100% positive then. Okay, so all coefficient, this is plus, and this is plus. And for second order, for a second order equation, if all coefficients are positive, all roots are in LHP. You don't need RH for the second order, right? Since it is the second order only, dear, it is only the second order, all coefficients, ध्यान देना, all coefficients are positive, right? So what I am doing, whatever few important points about the RH, I will tell here only. Then separately, if discussion required, I will do that. But पहले root locus को focus करते हैं. And within that, some important things about RH. जितना होगा वो यहाँ पे भी करेंगे. So all coefficients are positive, right? So all roots are in LHP. That means there will be no intersection with the j omega axis, right? All right. अरे ग्रेट, कॉन्ग्रेचुलेशंस दिव्याजीत. ठीक है. यस, एंड आई एम इन नोएडा दिस मंथ. आप आ जाओ कभी भी, है ना. जस्ट इन्फॉर्म मी, ड्रॉप मी द मैसेज ऑन टेलीग्राम और कॉल मी. आई विल बी देयर इन द ऑफिस. ठीक है दिव्याजीत. ओके, एंड गुड, कॉन्ग्रेचुलेशंस फॉर योर जॉब. आगे आ जाते गाइस. ठीक है. सो now the next step what I told you is the angle of departure and angle of arrival, but that is there for the complex poles and complex zero. Do I have complex poles? Do I have complex zeros? No, na. We don't have complex poles, we don't have complex zeros. Okay, so क्या करना पड़ेगा? We don't have the complex poles, we don't have the complex zeros. Let us stop here and let us start the sketching of this. Let me just come back and show you the proper sketch for this one. Okay, let us take a proper blank slide here. And then after sketching also, whatever few important things we learn, I'll highlight those things here. ठीक है जी? Everybody, now please come here. First, okay, first of all, let us draw the poles and zeros. So I have the poles at origin, at -1, at -2. This is the 0. -2 पे 0, -1 we have a pole at 0. Okay. Asymptote, again I tell you, for one asymptote it's simple. We know the angle is 180 degree. We don't need it actually. 180 degree was mind mein rakhna hai, but still, first problem, let us draw it. So the centroid of the asymptote was equal to 1 and asymptote was towards 180 degree line. 180 degree is what? Negative x-axis. 180 degree is what? Negative x-axis. So this is the centroid location, which is 1, and from there I have started a line at the 180 degree. 180 degree is negative x-axis. Okay? Now after plotting the asymptote, let us draw the roots. The root locus branches will start, okay, all right, great. Yeah, definitely it will help you in anywhere where the control system or any of the technical subjects that we are covering, okay, because covering the concepts primarily, so it will be helpful everywhere. ठीक है, अब आ जाते हैं यहाँ पे. Root locus branches will start from the open loop poles. So the root locus branches should start from the open loop poles. And I have told you, as per the previous step number 8, it will be to the left of -2 and it will be between -1 and 0. Acha. Then let me also complete that breakaway discussion. So I have the two breakaway points, -2 plus √2, -2 minus √2. So this is approximately -3.41, assuming √2 as 1.41, and this will be how much? -0.41 हटा दिया तो -0.51. Sorry, 59. -0.59. Are both of them breakaway? Okay, मैंने क्या बोला था? For the solution of dk by ds equal to 0, it must lie on the root locus. So -0.59. पहले देख लो, पहले -0.59. -0.59 is somewhere here. ठीक है, इसको मैंने बोल दिया S1, इसको मैंने बोल दिया S2. S2 is -3.41. -3.41. Okay, this is S2. This is the S1. So both of them are lying on the root locus. Both of them are valid. Right? Both of them are valid. Valid and valid. Sometimes it may not be. ठीक है? हाँ, there are the two poles, Chinmoy. बिल्कुल सही. ठीक है. So root locus branches will start from the open loop poles where? So ध्यान देना, this is your region of existence. This is the portion on the root locus. This is the portion on the real axis where root locus will exist. Okay. So from -1, if the branch has to start, it will start from right, not to the left, because here root locus is not allowed. So it will start to the right. Dear, it will start to the right. So from here, I have now started a branch towards right. I have now started the branch towards right. इसको पहले ही यहाँ से bold करके बना देते हैं. Look at this. So the root locus exists here. The root locus exists here. That step number 8 is again repeated here. Okay. So whatever branch is starting from -1 will be towards the right. Whatever branch is starting from 0 will be towards the left. Just wait करना, it has. Wait a minute. ठीक है? So what is the first clear picture? That there are two branches starting and traveling in the opposite direction. So they will have a collision. They will have an intersection. That point of intersection is the breakaway condition. That point of intersection is the breakaway condition. So they are traveling in the opposite direction. They are ready to intersect. At what point? At the first breakaway point, -0.59. Okay, approximately take it here. They come here, they intersect. Okay, they come and intersect, and now they are going to travel in the complex plane. Where? Now, they are going to travel in the complex plane. Be logical in solving, right? Where they should be going? Towards the left or towards the right? Number one, I told you, there is not going to be any intersection with the j omega axis. Number one. Acha, forget that. Where they should be going? They should be going towards the conclusions. Conclusions kahan pe hona hai? The conclusions, the termination is on the open loop 0 and infinity. There are two conclusions. One is open loop 0 and one is towards infinity, 180 degree infinity. So both are towards left, na? Both are towards left. So this is not the correct case. So they are going to go towards left. Okay, and root locus is symmetric because I told you if there is a conjugate complex root, it will be conjugate. So if there is a root going to the top, there will be a root going to the bottom. So there will be two symmetric branches. ठीक है. अच्छा, आप कैसे होगा? Think logically, right? One of them concludes at open loop 0. One of them concludes at infinity. Can I say this is my root locus? बोला ना सर कंक्लूड करना है तो one of them conclude at 0, one of them going towards the asymptote. Is that the correct root locus? No, root locus always has to be symmetric. They cannot follow this pattern because if there is a x plus root y, if there is a x plus jy root here, there has to be x minus jy root here, conjugate theory ke according. So that is why this is not correct and they have to go symmetrically. Acha, symmetrically they both can't come and close here. One of them has to go to infinity. So what is the condition in that case? They will, because of that symmetry, they will travel and they will come once again and meet at a common point. Because of the symmetry, you have to come and make them land on a common point. Symmetry says that make them land on a common point. Make them land on a common point. And that common point is the next point of intersection, and that is your break-in point. So see, during the breakaway calculation, we had the two conditions, the minus 3.41, that is also valid. I very rectified for you. So that is going to become your break-in point actually. And after that, dear, after that, one of them will go towards the open loop 0, finish. Another one will go towards the asymptote. That's it. Okay, this is where the root locus started. Root locus starts with k equal to 0. This is also k equal to 0. And root locus dives for k tending to infinity. This is k tending to infinity. And this is also going to go towards the k tending to the infinity, dear. This is also going to go towards the k tending to infinity. Okay, dear? Now, this particular point, minus of how much? Minus 0.59. Yeah, let us write down. Sorry. Let us say this point is S1 and this point S1 is minus 2 plus root 2. This is known as the breakaway point. And this next point, suppose this is S2, this S2 that is minus 2 minus root 2, this is known as the break-in point. Sir, what is this? BIN, I will write it as BIP, that is known as the break-in. Okay. Let me draw the arrows here. There are few more properties that we will extract with the same root locus. ठीक है जी. So there were two breakaway conditions. One of them is actually breakaway. One of them is the break-in. When two root locus branches travel on the real axis and move towards the complex plane, that is breakaway. When two root locus branches travel from the complex plane, intersect on the real axis and then travel on the real axis, that is the break-in. ये ध्यान रखना. That is known as what? That is known as the break-in. Clear everybody? Next condition पे आ जाते हैं. चलो बढ़िया. Now what should be the next condition, dear? What should be the next condition, dear? Now next condition देखेंगे यहाँ पे हम. Now let me ask you a next question here. This part is okay, complete. The root locus is complete. But next question. Find the value of k at the breakaway point and break-in point. How do you find the value of k at the breakaway point and the break-in point? How do you find the value of k at the breakaway point and the break-in point? Yeah, how do you find the value of k at any point on the root locus? Right. By breakaway point and break-in point, they are on the root locus only, na? They are on the root locus. They are not somewhere else. Right. Any point lying on the root locus will satisfy. ये रहा method number 1. I'll tell you two cases here. Any point lying on the root locus will satisfy what? I'll tell you two methods here. Number 1, mod GSHS equal to 1. Mod GSHS equal to the 1. ठीक है? Mod GSHS equal to 1. Yeah, directly substitute in characteristic equation. Okay, not closed loop transfer function, Abhishek. Right? In the characteristic equation. In the characteristic equation. So look into this method number 1. अब GSHS तो given है ना मेरे को. GSHS is k s plus 2 upon s plus 1. GSHS, right? मॉड GSHS सॉरी, है ना। तो मॉडुलस ऑफ के एस प्लस 2 डिवाइडेड बाय एस एस प्लस 1 शुड बी 1। यहां से भी सिंपल आ जाएगा, राइट, यहां से भी सिंपल आ जाएगा। सो व्हाट इज द S1 -2 plus root 2, that was minus 0.59, right? So k into minus 0.59 plus 2 divided by minus 0.59 into minus 0.59 plus 1, इसका मॉडुलस 1 के बराबर होना चाहिए। So tell me what should be the value of k from here. Tell me what should be the value of k from here. निकाल लेते हैं quickly, and because it's the magnitude, all minus signs will go away. Tell me 0.17, just rectify your calculations and tell me, is it 0.17, right? And S2 minus 2 minus root 2, if I put that as minus 3.41, ये 0.59 था, sorry, right? So then modulus of k into minus 3.41 plus 2 divided by minus 3.41 plus 1. Whole of this mod equal to 1. Rest is your calculated duty. It will perform the duty and give you the answer. So let us write down what is the answer going to come up. Yeah. 5.83. Just check out approximately. The 5.83 will be the answer. Everybody. Approximately the 5.83 will be the answer. Approximately the 5.83 will be the answer. ठीक है. So the value of k at these points, this is also known to us now. K here is, let us write down, at the breakaway minus 2 plus root 2, k was 0.17, and here the value of k is 5.83. अच्छा, what is the method number 2? Let me tell you the method number 2 also. ठीक है, वो शायद टाइप एरर हो गया रवि, ठीक है, 5.83 it is. 5.83, there I have written 5.83, perfect. अच्छा, what is that method number 2 I am referring to? This is the method number 1, very basic. Method number 2. At any point, the direct formula, the direct shortcut, at any point on root locus, how do you calculate the value of the k? How do you calculate the value of k? Yeah, as some of you are already mentioning it, like Rupesh and Niharika. Okay, distance of the point from the poles, okay, and product of all this. लिख देते हैं. You have to multiply all those distances if there are multiple distances. Product of distances from poles to that point is divided by the product of distances from zeros to that point. That also can be taken as a formula, dear. ठीक है? That also can be taken as a formula. Clear, everybody? So ये भी कर सकते हैं quickly. Now your point is where it is minus 2 plus root 2, that is minus 0.59. This distance plus this distance divided by this much of the distance. Okay, divided by this much of the distance. ठीक है? So you can try this method at your own, but I have given you the formula. This much of the distance, this much of the distance, and this much of the distance. ये यहाँ का आ जाएगा. Then for second point, then this distance, and then divided by this distance. Are you getting it? So according to the method number 2, chalo, I will write down the values here. Right? For S1, which is minus 2 plus root 2 or minus 0.59, what should be the value of k? How much is this distance? ये तो origin वाला distance हो गया. So that is the distance means of course the magnitude. Distance of course will be taken as positive, na? So plus 0.59 multiplied by the second distance. What is this distance? 1 and 0.59. So 0.41 divided by 0.5120. 0.5122. तो कितना होगा? 0.59 to 2, 1.41. Calculate, you should get 0.17. S2 की बात करें तो S2 is -2 minus root 2, that is minus 3.41. So what should be K? अगर इस point की बात करेंगे तो distance of first pole, that is origin, so that is 3.41. Total distance 3.41. Then this much of the distance, ये कितना होगा? 3.41 and this is 1, तो 2.41 divided by ये distance 3.41 and 2, तो 1.41. 1.41 या आ जाएगा 5.83. Rectify once again, है ना? So according to the method number 2 also you can calculate. I have given you those calculations here. ठीक है जी? चलो, this is done. What is the value of K at the breakaway point and break-in point? You can either solve by the basics or by the distance formula. Now, moving ahead to the next part of the question that was mentioned here. So see, within one question, see, don't take it as one question. You are learning several things. Because ये जो question बोला ना मैंने, ये जो question मैंने बोला, find the value of K. This is sometimes many a times you will see a question in the gate coming up. Find the value of K if this point lies on the root locus. You don't have to sketch the root locus there. You just have to use these conditions, method 1 or method 2. That's it. ठीक है? So very important thing. Next a separate question that can be there. Given a root locus in the gate, find the range of K for the system to be underdamped, overdamped, critically damped, negatively damped. Tell me. Okay. Underdamped, overdamped, critically damped, and undamped. देखो, undamped, negatively damped when roots are in RHP. Roots are in RHP for no value of K. So fourth answer तो clear हो गया. I'm just writing the answers here. For no value of K, there will be the negatively damping, right? Critically damped. Roots are real and equal. That is what we have revised yesterday also. Now, what is the critically damped? The roots should be real and equal. Sir, where are the roots real and equal? Tell me. Root locus given hai aapko. Where are the roots real and equal? Okay, both the roots should be on real axis and equal. Equal means they are on the same location. Same location means they have intersected. So one is the breakaway point, one is the break-in point. One is the breakaway point, one is the break-in point. Is that clear, everybody? One is the breakaway point, one is the break-in point. Okay, so the roots are real and equal. That is at the breakaway point and the break-in point. Question में क्या बोला है? Find a range of K and the value of K. So here you will get the answer. K is equal to 0.17 and 5.83. For two values of K, roots are real and equal. 0.17, 5.83. ये third answer done हो गया. The system is underdamped and overdamped. First और second को भी देख लेते हैं. What is the condition for underdamped? Underdamped, roots are not real, roots are complex conjugate in LHP. Roots are complex conjugate in LHP. This is one complex conjugate branch, this is another complex conjugate branch. They start after the breakaway point and they exist till the break-in point. Okay, so it is from the breakaway point up to the break-in point, that is K equal to 0.17 up to the K equal to 5.83. Between the breakaway and break-in, they were moving in the complex plane. Right? So answer again, 0.17 up to 5.83. Let's go and write down the answer there. 0.17 less than K less than 5.83. So K is between 0.17 and 5.83. Okay. Now done. Overdamped. Tell me, what should be the condition for overdamping? What should be the condition for the overdamping? Tell me. So overdamping, पहले तो condition recall किया. Roots are real but unequal. Equal पे तो critically damped हो जाता है. So look into this section. Root is real, another root is also real, but they are traveling on different parts of the real axis. Here they intersect, but before intersection they are unequal. Na? They start from 0 and -1, they travel towards each other. So before they intersect, they are not equal to each other. They are on different places. Right? So that will happen for what value of K? Starting 0 up to 0.17. This is also starting 0 to 0.17. Okay, then they intersect. Then they are complex. Forget that. Then they again intersect. Critically damped. Critically damped. Then, after the final intersection, after the break-in point, they again travel on the real axis on different parts. That means again they become unequal. Real and unequal. Again they become real and unequal. So after the break-in point, that is after 5.83. After 5.83. Clear, everybody? So let me write down the answers then. Okay, so roots are real and equal, so there will be the two cases here. Number one, k is between 0, say 0.17, so k less than 0.7, and next is k greater than 5.83, so up to the infinity. 5.83 less than k less than infinity, or you can simply write k greater than 5.83. This is the value of k for the system to be overdamped. Now you will think, sir, this overdamped, critically damped, underdamped, this is very simple. I can find out from the GS only. Yes, you can. But when such a question is coming, dear, GS will not be given. Don't think like that कि वो दोनों चीजें आपसे GS भी देंगे, root locus भी देंगे. No. For such a question in GATE, they can give you a root locus diagram with the necessary points specified, and then they'll ask you, tell us the answer. Tell us for what value of k there will be underdamping, overdamping, etc. They can ask you any one of the parameters. Okay, don't worry, we have done both. Okay. Chalo, done hai? Okay, done hai. Now, one more case. Between the breakaway point and the break-in point, when you look into the exact, see, this is the rough and the quick sketching of the root locus. But when you go for point-to-point sketching, okay, taking the equation of curves, you are going to find that this is going to form a circle. This is going to form a circle. This is exactly going to give you an equation of circle. We can verify using angle GSHS equal to 180 degree. Okay, circle. It can be proved using angle GSHS equal to 180 degree. So इसको वापस copy करते हैं. Let me write down some results here. Let this root locus be here. Let this root locus be here. Let me just copy this slide here. Correct? Yeah. So as I'm telling you, this is going to be a circle. Okay, that can be proved using, ये भी hint कर देता हूँ, we don't need any proof here. This can be proved using angle GSHS equal to plus minus 180 degree. ठीक है. But if it is a circle, it has to have a center and a radius. It has to have a center and a radius. Look into this, guys. What is going to be the radius of the circle? So diameter पता चल जाएगा यहाँ से. What is the diameter of the circle? It is between, it is S2 minus S1. It is S2 minus S1. Yeah, sometimes it can be S1 or S2 depending on the orientation. So what is the diameter? What is the diameter? यहाँ से समझ में आ गया कि what is the diameter? It is S2 minus S1 का modulus. Modulus of S1 minus S2. And what is the center of the circle? What is the center of the circle? Right, center कहाँ पे मिलेगा? It will be at the midpoint. So this is the diameter line. So it is center should be the midpoint. The center should be the midpoint of S1 and S2, isn't it? It should be the midpoint of S1 and S2. So regarding to the circle, important formulas here, right? Regarding to the circle, important formulas I will wrote down here. Sometimes a direct objective question हो सकता है. So radius of the circle will be, ये diameter है, let me write down the radius formula. It is modulus of S1 minus S2 divided by 2, and the center of the circle would be x comma 0, where midpoint formula is a plus b by 2, midpoint of 2 formula, midpoint of 2 points, S1 plus S2 divided by 2 comma 0. Clear, everybody? This is what is the important things regarding to the circle. Circle has two important things. If you know, you can sketch it. That is the center and the radius. So this also can be noted down. Okay, this also can be noted down. चलो done है, बढ़िया. अगला case निकालते हैं now. Okay, let us go towards the next case then. A unity feedback system has GSHS K upon S, S plus 4, S square plus 4S plus 20. Sketch the root locus. One more, let us take the sketching. So see what you have learned with the previous sketching. With the previous sketching itself, it is not only sketching, it's not a conventional problem we are trying to do, but with that sketching, small important points, small techniques, some shortcuts, some formula we are discussing, right? So let us once again take a next problem and we'll be discussing few more things here. We'll be discussing the few more things here, right? Quickly do the basic calculation, open loop poles, open loop zeros, etc. here. Chalo. A unity feedback system has GSHS equal to K by S, S plus 4, S square plus 4S plus 20. S square plus 4S plus 20. Okay, so let us start with the basic calculation. What are the open loop zeros? Nil. You don't see any open loop zero here. What are the open loop poles here? That is going to be S equal to 0 and minus 4, and minus 4 plus minus root over b square minus 4ac divided by 2a. So your open loop poles are 0, minus 4, minus 2 plus minus under root of minus 64 j8 divide by 2 kiya to j4 plus minus 2 plus minus j4. Minus 2 plus minus j4. Now, since how many poles are there? 4. And since there are the complex conjugate pole, there are the complex poles, and because there are complex poles, you will talk about angle of departure in this question. So with this question, I will explain you what angle of departure can be. With this question, I would like to explain you what is the angle of departure. Okay. With this question, I would like to explain you what is the angle of departure. What should be the angle of departure? ठीक है जी. Angle of departure. Chalo, cool. Okay, so we'll understand that angle of departure. यहाँ पहले angle of departure ही समझ लेते हैं. Rest all the calculations you can do easily. So let us talk about that angle of departure. How to calculate the angle of departure here? How to calculate the angle of departure here? For that, I will draw the pole zero diagram and explain you the method. I'll draw that pole zero diagram. What was the formula? एक बार फिर से revise करें. What is the formula? It is given by the formula 180 degree minus phi p minus phi z, where phi p and phi z has to be calculated. Phi p is sum of angles subtended by that complex pole with respect to all other poles. तो diagram से समझेंगे, not like this words. Let me draw up that pole zero diagram actually. Okay, so we have the poles at 0 and minus 4, minus 2 plus minus j4. Okay, so let us place these poles. We have the poles at 0, we have the poles at minus 2 plus j4. So let us say this one approximately. So these are the complex poles of the concern, and then we have, that is a minus 4. This one is minus 4, this one is 0, minus 2 plus j4, minus 2 minus j4. ठीक है? चलो. Now, suppose I want to calculate the angle of departure of this particular guy. What is the angle of departure of this guy? So what I will do is, first of all, dear, join this with respect to all the other poles and zeros. What? Join this with respect to all the other poles and zeros. Okay, all other poles and zeros. There is no other zero, but I'm just generally telling you. With respect to all the other poles and zeros, just join this. ठीक है, मैंने join कर लिया. Just join this. Okay. Very clearly from this picture, there is no other zero. There is no other zero. So what is going to be the phi z? That is 0. Because phi z is the sum of angles subtended by the zeros, but there is no zero, so no angle. But what about phi p? As I told you, phi p is the sum of angles subtended by all other poles. So there are three other poles. Okay, let us say this one is the angle, that is going to be phi p1, plus let us say this one is the angle, that is phi p2, and always, you know, angle should be measured with respect to the positive x-axis. With respect to what? The positive x-axis. And third case ये हो गया phi p2 भी, third case phi p3, that is the angle subtended by its conjugate part, phi p3. That is the angle to be subtended by its conjugate part, and that is always 90 degree. Okay, a complex root will subtend the angle with conjugate part 90 degree because that will make a vertical line. X coordinate same hai, that will make a vertical line. So phi p3 is anyways not only here 90 degree. Let us target the phi p1 and the phi p2 calculation. So sir, what is the phi p1? Phi p1 is actually the exterior angle of the triangle. Okay, so let us calculate 180 minus interior angle, minus this interior angle, right? What is this interior angle? Tan inverse height कितना दिख रहा है? That is up to the 4 divided by this base, that is 2. So this angle is known as 180 degree minus tan inverse 2. 180 degree minus the tan inverse 2. 180 degree minus the tan inverse 2. ठीक है? What about the phi p2? Phi p2, that is only the interior angle. So simply I will apply the formula. Tan inverse height 4 है, base 2 है, so tan inverse 4 by 2, or simply tan inverse 2. Don't calculate tan inverse 2 also, because when you add them, you're just going to cancel. Okay. So dear, after having these values, let us come here and write down these values. So what is the phi z? Is 0 degree. What is the phi p? It is phi p1, phi p2, phi p3, which I have calculated. What should be the value for phi p1? 180 minus tan inverse 2 plus phi p2 tan inverse 2 plus phi p3, which is 90 degree. Tan inverse 2 got cancelled. This is simply 270 degree. So finally, what is the angle of departure? That should be 180 degree minus phi p minus phi z. So this is going to be minus 90 degree. What should be the angle of departure, sir? That is going to be the minus 90 degree. The angle of departure is the minus 90 degree. Done, sir. Okay, now the rest of the other calculations, as I told you, asymptotes की अगर बात करें, see, there are 4 branches starting at 4 poles but terminating on the zeros, but there are no zeros, so all the 4 branches will turn towards asymptotes. All the 4 branches will turn towards the asymptote. So let us quickly write down the asymptote calculation. Let us quickly write down the asymptote calculation. तो देखो asymptote का calculation कैसे होगा यहाँ पे? So there will be the 4 asymptotes. There will be the 4 asymptotes, and whenever 4 asymptotes, I told you the angle depends only on the quantity of asymptotes, not on the location of pole and zeros. So theta for 4 asymptotes already I have calculated, so I will not repeat the formula. 45, 135, 225 and 315. Odd multiple of 180. 180 को 4 से 180 को 4 से divide करो. Divide into 4 equal part, that is 45, and then odd multiple of 45. Okay. Then what is the centroid? It is given by the formula summation of poles. Poles आपको दिख ही रहे हैं यहाँ पे. Minus summation of zeros. So there are no zeros, divided by p minus z. Okay. Now, if there is a complex conjugate pole, you can only consider its real part because imaginary part will get cancelled, or even if you write no harm. Okay, so ये answer आ गया x equal to the minus 2. Okay, so this is sorted. Centroid is also known to me, x equal to the minus 2, sir. Okay, x equal to the minus 2. Okay, done. What are the breakaway points? What are the breakaway points? Next calculation यहाँ पे लिखेंगे, important one. Again, breakaway. So see, why I am repeating these steps? Guys, again I am telling you, na, many of these points are individual questions. Many of these points, Sometimes you will feel question is only find a centroid, find the angle of asymptotes on the real axis. So these are individual questions. So with every complete question, discrete questions भी solve हो रहा है. Breakaway points के लिए, first of all I need the characteristic equation, and that is going to be 1 plus k upon s plus 4, s square plus 4s plus 20, s square plus 4s plus 20, एक बार verify करेंगे, correct, equal to the 0, right? So what is the k? We have to write down k as a function of s. We have to write down k as a function of s, and that is going to be minus of s को multiply किया, s square plus 4s, then we have s square plus 4s plus 20. Let me simplify this. So k will be minus of, this is like square s power 4, 16s square, 2ab 8s. This is done. Then you have the 20 with s square, and 24s are 80s, or the simplified form, k is equal to minus of s की power 4. This has to be s cube, sorry, 8s cube, 2ab वाला term था. Then 16s square and 20, 16, 20, 36s square plus 80s. Next, dk by ds equal to 0. Okay, so that is going to give you a cubic equation, 4s cube, 8 3s are 24s square plus 72s plus 80 equal to the 0. Equal to what? Equal to the 0. This is what is equal to 0. This is equal to 0. Now guys, don't worry, in GATE these days cubic equations आएगा भी तो कुछ hint के साथ आएगा, otherwise direct cubic equation will not come because that feature is not there in virtual calculator. But yeah, let us solve this because I want to explain many things with this question. So don't mind the cubic equation here. Let us write down its roots here actually. Let us write down its roots here directly. Okay, so what are the roots I am getting? Minus 2 and minus 2 plus minus j 2.45. Okay, minus 2 plus minus j 2.45, right? All of them will be breakaway points. All are valid breakaway points. एक step आपको मैं यहाँ पे direct बता रहा हूँ, because you know this cubic and this lengthy calculation will not be there at least, but to learn an important message I have taken this question. So all are valid, right? क्योंकि how you are going to verify they are valid, right? This is, I have verified this using, I verified this for you using, that is the angle GSHS. That is the angle GSHS plus minus 180 degree. Especially this one. Especially this one. Minus 2 is on the real axis. So real axis wala easily you can satisfy existence. Okay, the odd number property. But the complex one will be verified using the angle GSHS equal to plus minus 180 degree. So let's assume we have done this calculation. Let us go to the next. And next, intersection of the root locus. Intersection of the root locus on the real axis. Tell me, dear. What should be the intersection of the root locus on the real axis? The intersection of the root locus on the real axis. So what will I do for this one? Okay, for this I need the characteristic equation, because as I told you, for this we apply the RH criteria. Characteristic equation is already simplified in terms of k. Let us arrange once again. So we will have s power 4, 8s cube, 36 and 80, 36 s square plus 80s plus of k equal to the 0. Now what is the method you are going to apply for this? RH. Okay, what is the intersection point for the imaginary axis? Now this is also one important question of RH. This is also one important question for RH. What is the value of k for which the roots will lie on the j omega axis? Sorry, ye j omega, I'm sorry, hai na? Intersection of root locus with the j omega axis. With the j omega axis, ठीक है? So यहाँ पे एक RH का question भी आ जाएगा. Okay, let us discuss that. Or as I told you, I will whenever required, I'll mix up that RH case. So this is like a RH regular question also. This is also Rao-Hurwitz regular question. Find the k for the roots to lie on the j omega axis. Okay, that is system to be ऐसा भी क्वेश्चन हो सकता है, find the value of k for the system to be marginally stable. Whenever the system is marginally stable, right, whenever the system is marginally stable, it is going to be oscillatory. It is going to be oscillatory. So also find the frequency of oscillations. Also find the frequency of oscillations. ठीक है, one very regular question of RH है, that is by default we have to solve here. Again I'm telling you, for quick sketching this may not be required. We can draw, we know root locus will intersect somewhere on the imaginary axis. We can just go and show that intersection. But I'm not focusing only on sketching. Every step is a message for you. Every step is a learning, and we are learning here. ठीक है, तो ध्यान देना, we are learning here. So let us complete that. So we'll feed into the Routh array. अब यहाँ पे आ जाएगा Routh array. We have s power 4, s power 3 alternate rows. So we have 1, 36 and k here, 1 and the 36 and the k. And then we have alternate odd coefficients 8 and 80. This part is 8, this is 80, this is going to be 0. Then s power 2 next row, that is 8 into 36 minus 80. Okay, you know this to solve the RH. Okay, so that is 8 into 36 cross multiply minus 1 into 80. Minus 1 into 80 divided by 8. Divided by, just keep noting. Just keep noting it. Okay, so what is this? 8 cancel, 36 minus 10. So this will be 26. Now I will erase and finally write down the answer, 26. Next, first column also remains to be fixed. If you have any doubts in RH, ask me separately. First column remains to be fixed. Now try with the next column. So 8 into k minus 0 divide by 8. Divide by 8. Okay, I'll show you again. 8 into k minus 0 divide by 8. So what is only left is going to be the k. So this has to be k. Last element of a row will always be 0 because there is no other column there. S raised to the power 1. 26 into 80 minus 8k. So this is 26 into 80 minus 8k divided by the 26. Divided by the 26. Divided by the first element of the above row always. So this is going to be 80 minus 8k by 26. इसको ऐसे ही लिख देते हैं, 80 minus 8k by 26. This is 0 because the entire column is 0. Even if you cross multiply, you are going to get 0, 0. Last element anyway is 0. Now come to the final row, that is the s power 0. S power 0, right? So x into k minus 0. So minus 0 हटा देते हैं. Suppose this is x. X into k again divide by x. So only k is going to be left. This is 0 because next row is 0. Last element always 0. Clear everybody? Okay. Now, if I want to talk about the stability, for stability in, using the RH criteria, what do you need? For pure stability, all roots in LHP, what do you need? There are two conditions that you must check. थोड़ा सा RH को revise कर रहे हैं यहाँ पे. There are two conditions that you must check. Number 1, फर्स्ट कॉलम की बात करेंगे. No sign change in first column. And number 2, no ROZ. Number 2, sir, no ROZ. What is ROZ? Row of zeros. Sir, what is ROZ? ROZ is known as the row of zeros. There should not be any row of zeros. Okay, so no sign change in the first column and no row of 0. Because if there is a row of 0, system could be best marginally stable or unstable as well. It cannot be purely stable. So there should not be any ROZ. Okay, row of zeros. ROZ means row of zeros. Take a note down. So आपको क्या चाहिए according to this conditions? So according to the first condition, you need 80 minus 8k by 26 should be strictly positive because positive. So this also has to be positive, right? This also has to be positive. Not even equal to 0. I am taking greater than 0 because equal to 0 किया ना, here I will get the row of 0. ठीक है? and the next element k also greater than 0, right? यहां से क्या आ जाना चाहिए, 10 cancelled, k will be less than 26 into 10, 260. So what is the range of k? K should be greater than 0 but less than the 260. This is one type of RH question also. Find the range of k for the system to be stable, 0 to 260. Now if you put k equal to 260, yeah, if you take k greater than 260, dear, if you now take the k greater than 260, what is going to happen? When you put the k greater than 260, this is going to be negative in sign. I have taken positive. Now take k greater than 260. This coefficient will become minus. So plus, 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 minus, plus. K positively greater than 260 means positive. So what is now happening? There are two sign changes. There are two sign changes in the first column. So there will be two RHP roots and system will be unstable. System will be unstable, right? So there will be two sign changes, dear. There will be two sign changes in the first column, right? And I can say that there are going to be the two RHP roots. Number of sign changes in the first column will correspond to the RHP root. So there are going to be the two RHP roots and system is, even if one RHP root, system is unstable. Okay. Now what happens exactly at the 260? Exactly at the 260. So it's a boundary between stability and instability. Definitely system will be marginally stable there. And at k equal to 260, what is going to be your S power 1 rho? What is going to be your S power 1 rho? Exactly at 260, this 80 minus 80 will become 0. Other two elements are anyway 0. So this is going to look like, and hence you get a row completely filled with 0. That is what is RO, 0 of zeros. What do you get here, sir? Row of zeros. What do you get here? Row of zeros. So exactly at k equal to 260, you get the row of zeros. You get the row of zeros, right? Okay, so system is marginally stable for k equal to 0. System will intersect the j omega axis at k equal to 0. What is the frequency of oscillation then? So for the frequency of oscillation, whenever there is a row of 0, we form the auxiliary equation. Sir, what is the auxiliary equation? Auxiliary equation is formed the row by using the row above the ROZ. Above the ROZ. So what is the row above the ROZ? S power 2 row, which is 26k and 0. Which is 26k and 0, where the k has to be 260. Okay. So what is the auxiliary equation? Ye to ho gaya row. Okay, what is the auxiliary equation? 26 is the coefficient and there is the S square row. So 26 S square plus k is 260. Alternate coefficients are there. So it has to be S power 0. Done. That is the last one. Okay. तो यहां से आ गया ना 26 S square plus 260 is equal to 0. So S square will be the minus 10 and S is equal to plus minus J under root 10. And that S can be compared with plus minus J omega N. So that omega N becomes the root 10 here. That becomes the frequency of oscillation here. That becomes the frequency of oscillation there. So plus omega N is equal to the root 10. Okay. Chalo. Right. So angle of departure is done. Routh-Hurwitz को समझ लिया थोड़ा बहुत यहाँ पे. I hope this has give you a little bit revision of the RH also. Right. If required, we'll take some more separate questions on RH. Okay, but पहले root locus complete करते हैं. So RH also in a sense revised here. Good morning, Rohit. And we have done the breakaway and asymptote, all regular calculations. Now let us come to the root locus plot, dear. Now let us come to the root locus plot. Now let us come to the root locus plot, everybody. Weekly. Intersection of root locus on the real axis. I will show you directly here. So again, I tell you, don't treat this as a conventional problem because this is giving you many of the points concepts. Why I am taking a conventional type of problem? So that you learn many of the things within the same question. Have you learned Have you learned several points within the same question? Tell me in the comment box, dear. That is why we are discussing conventional question. Otherwise, there is no point. But to learn different concepts within a single question. Okay, so are we successful in that? Please quickly tell me in the comment box, dear. By the time, let me draw the pole zeros at least. Yes, chalo, badhiya. Now, where will the root locus exist on the real axis, dear? Where will the root locus exist on the where will the root locus exist on the real axis? And if you are really learning also, then do not forget to like the session. Keep liking the session. Keep putting your attendance if you have missed it. So, root locus will exist on the section of real axis. Again, forward poles and zeros. Acha, two more poles here. Usko bhi bana dete hain. This is the next pole, -2 plus J4, and this is going to be the next nearly -2 minus J4, correct? And this is the next one. Okay. Now, where will the root locus exist on the real axis? Will it exist here? Will it exist here? If I see towards the forward, area, how many? 1, 2, 3, 4. No, this is an even number. This is a even number. Okay. Acha, will the root locus exist here? So if I see before -2, dhyan dena. If I see before -2, right, how many poles and zeros? Actually 3. 2 complex conjugate and 1. And if I see from here, there is only 1. Yes, both are odd. Yes, the root locus will exist here. Will the root locus exist here? Here I have 0 poles and zeros. Forward number of poles and zeros is nil. So root locus should not exist on the right side. Should not exist on the right side. Done hai? So root locus will exist only on this section. Let us draw this section separately here once again. That is between the -4 to the 0. Between the -4 to the 0. Between the -4 to the 0. That is the existence on the real axis. Okay. Acha. Before that also, let me also draw the asymptotes for you first. So what was the centroid of the asymptote? The asymptote centroid was also -2. The asymptote centroid also -2 and at 45 degree. The first one, 45 degree. Then let me draw the third one pehle yahan pe. Sorry, this is the fourth one. And इसी को extend करते जाइए. This is the second one. These are the asymptotes. Done? These are the asymptotes. And now let me reintroduce that particular branch. Okay, everybody, now come on quickly. The root locus start from the open loop poles. Okay, there are 4 open loop poles. Yahan se bhi branch start hoga. So just wait for that. The root locus will start from the open loop poles. From -4 it will start right. From the 0 it will start to the left because of the odd number property I've already discussed. So once again guys, 2 branches traveling in the opposite direction, so they have to intersect, they have to collide. So they will collide at the breakaway point. What are my breakaway calculation? -2. One of the real breakaway point is -2. So they will come and intersect here. That is at the -2. That is at the -2. Okay, so make them come and intersect till the -2. Now further, 2 more branches, dhyan dena, 2 more branches are going to start from the complex pole, and whenever a branch depart or starts from complex pole, it has an angle of departure. It has what? It has an angle of departure. Now, what was the angle of departure of this pole? Let us go back and write down. What was the angle of departure there? We have done all these calculations. Come back here. What is the angle of departure? Minus 90. Acha, this is the angle of departure. This is the angle of departure of minus 2 plus J4. What will be the angle of departure of the other pole? What we have calculated, angle of departure for minus 2 plus J4 is minus 90 degree. And why I have not calculated the other one? There are two complex poles, because the angle of departure for the conjugate pole will just be opposite in sign. So that should become the plus 90 degree. That is always opposite in sign. So that should be the plus 90 degree. Clear? That should be the plus 90 degree. That should be what? The plus 90 degree. The plus 90 degree. Done? Eh? That should be equal to the plus 90 degree. Okay, chalo. Right. So let's go back to the root locus. That should be the plus 90 degree. So yahan se jo branch start hogi, that is at the, this one was minus 90 degree. The branch that is going to start from here should be at the minus 90 degree angle. Where is minus? Okay, the angle is always taken with respect to the x-axis. That is why I have first created a line. That is why I have first created a line which is parallel to the x-axis, and now measure minus 90 from here. So minus, bole to clockwise, clockwise 90. 90 means you become perpendicular. You go vertically down. You go vertically down. Right. Similarly, if I want to start a branch from here, if I want to start the branch from here, this is having the angle as plus 90, right? Plus means anti-clockwise. So anti-clockwise 90, you go vertically upwards, right? You go what? You go vertically upwards, right? So there is a branch starting vertically downwards from here. There will be a branch जो यहाँ से ऊपर जाएगा. First complete the picture of the upper half plane. Lower half plane is symmetric anyways. So focus here. There is a branch traveling down. Now what happened? We left the problem at intersection. Two branches started from 0 and minus 4. They intersected at the breakaway point minus 2. There are two more breakaway points. Yaad kijiye. There are two more breakaway points. Minus 2 plus J 2.25. 2.45. There is one more breakaway point here. That is at minus 2 plus J 2.45. This is one more breakaway point ready. So what is the picture now? One of the branch, because of angle of departure 90 degree, it travels downwards, vertically down. So the intersection that happened, from this intersection, one of the branch is going to travel vertically upwards now, and they will intersect here. So यहाँ से approximately बना देते हैं. This is traveling vertically upwards. Okay, this is traveling vertically upwards till this point, and this is traveling vertically downwards up to this point. They come and intersect here, and that is your next breakaway point. That is complex in nature. So there can be complex breakaway point also. There can be the complex breakaway point. Similarly, symmetric part बाद में बनाएंगे. So now after this breakaway, they will be moving towards the conclusion. There is no more breakaway point in the upper half plane. So they will move towards conclusion. Conclusion खत्म कहाँ पे होगा? Towards the asymptote. Towards the asymptotes, right? So now make them bend towards the asymptotes. Now this goes towards the asymptote. This one goes towards the left asymptote. For k tending to the infinity. For the k tending to the infinity. Right. The branches started for k equal to 0. K equal to 0. Similarly, let me complete the symmetric picture in the lower half plane. The root locus is symmetric with respect to the real axis. So same diagram in the lower half plane as well. From here, 90 degree, right? Make them come and collide approximately at this point. One of them will go towards the asymptote, right? One of them will go towards the left asymptote. For k tending to infinity. for k tending to infinity. ठीक है sir. What is this now? As I told you, what is this? This is minus 90 degree, which was the angle of departure, right? Here this is plus 90 degree. This was the angle of departure for the conjugate pole. For the conjugate pole. This is the complete root locus. This is known as the complete root locus. Acha, in that complete root locus, next point to mention here is, look into this. What is this? This is the intersection of root locus. This is the intersection of root locus with the j omega axis. I told you, for sketching, we exactly don't need the point. Sketch can be obtained directly, but I calculated it so that RH is also covered. So with that calculation, I have covered an important case of RH. So यहाँ पे what was the value obtained? Plus minus j root 10. So this is the upper point, plus j root 10. Right, that will be plus j nearly 3.16, and this has occurred for k equal to 260 degree. Right, so from k equal to 0 to infinity, there is a point 260 where I cut the j omega axis. Similarly, this one, ये जो है, this is s equal to minus j root 10, or this is minus j 3.16 for the k equal to the 260 again. For the k equal to the 260. Done, everybody? This is what it is. The complete root locus problem. Okay. Some more highlights, that this point minus 2 is your breakaway point. S equal to minus 2. And what is this? These are complex breakaway points. This is known as the complex breakaway condition. So there can be breakaway point, there can be break-in point, there can be complex breakaway points as well. Right? Even this one is complex. Even this one is complex. So there can be complex breakaway points also, you must be aware about. There can be the complex breakaway point also, you can be aware about that complex breakaway point. Done, everybody? All right. Okay, so angle of departure also we have just covered here. Angle of departure also we have just covered here. ठीक है? Chalo. Now very quickly, if I go to the next problem, okay, here we have GSHS equal to K S square plus 4 upon S plus 2. So here there will be the angle of arrival, dear. Here there is going to be the angle of arrival, because quickly, if you see here, if you just see here, what are the open loop poles? Open loop poles are 0 and minus 2. So there are two open loop poles. Open loop zeros, S square plus 4 equal to 0. So S equal to plus and minus J2. S equal to what? The plus and minus J2. Plus and minus J2. So how many zeros are there? So there are the two zeros. How many zeros are here? There are the two zeros there. Okay, there are the two zeros. These are the two zeros. These are the two zeros. Okay, so two poles and two zeros are there. Okay, so because there are two poles and two zeros, there is not going to be any asymptote. Right, we don't need any asymptotes here, na? Asymptotes तो तब चाहिए होता है when number of poles and zeros are unequal, to terminate the branches at infinity or to start the branches from infinity. But there are no asymptotes here. Are you getting it? There are no asymptotes here. Okay, so no asymptotic calculation. Let us first focus on the angle of arrival quickly. सिर्फ angle of arrival पे focus करेंगे हम. Right? Let us quickly focus. The intent of this question is angle of arrival. Method remains to be same. The intent is angle of arrival, and with that I will give you the quick sketch only. Okay, we can skip the further calculations right now. Okay, so angle of arrival के लिए ध्यान देना. Let me just plot the poles and zeros. Just like the previous question, we'll follow the same method here. Okay, so what are my poles? 0 and minus 2. Let me draw that. And my zeros are at plus minus J2. My zeros are at plus and minus J2. So this is the J2. This will be nearly minus J2. And I told you the method. We'll just stick to the same method. Okay, we are calculating the angle of arrival this time. Okay, so this is the angle subtended by one of the pole phi p1. This is the angle subtended by the another angle phi p2. And यहाँ से अगर horizontal line लिया, so this is the angle subtended by the 0 phi z1. Okay, what is the formula for angle of arrival, dear? The formula, as I told you, for angle of arrival was given by the 180 degree minus of phi z, angle of arrival, phi z minus phi p. Phi z minus phi p, right? So what should be the phi p here? Phi p is the sum of angles subtended by the poles, right? So phi p1 and phi p2, there are two poles. Phi p2 is clear, 90 degree, because that is a vertical line. What about the phi p1? That can be solved by the simple trigonometry, tan inverse, interior angle. Height is also 2, base is also 2. So this is tan inverse 145 degree, right? So what is the total phi p? It is 45 plus 90. And the total phi p here is 135 degree, right? What about the phi z? Phi z is just equal to phi z1. There is only one other zero. There is only one other zero, and the angle due to that is 90 degree. It's again a perpendicular vertical line. Vertical line means 90 degree angle. So ye bhi ho gaya, right? So I'll just put down this in the formula. My answer is for angle of arrival 180 degree minus of phi z, which is 90, minus of phi p, which is 135. So this is minus 45, 180 minus 45 is 225 degree. And once again, I will write down that angle of arrival for plus J2 for this one is 225 degree. So dear, what should be the angle of arrival for minus J2 for the conjugate 0? It is just opposite in sign. You don't have to calculate again. So that is minus 225 degree. Only using this knowledge, now I am completing the plot. Okay? Only using this knowledge, I am completing the plot. I'm telling you, the intent of this question is to explain you angle of arrival. But what have you learned? Whether it is angle of departure or angle of arrival, procedure is same. Thoda sa formula ka difference hai, but procedure is nearly the very same. So we have the pole at origin, we have the next pole at minus 2, and we have the 0 conjugate 0 at plus J2, and we have the next conjugate 0 at minus J2. Okay. Now, the branches will start where? The branches will start from the open loop poles. Okay. Where? Now, once again, existence dekhenge. Real axis existence. If I see from here towards the right, how many forward poles and zeros? 4. If I see from here, 1, 2, 3, odd number, bahut badhiya. So here, possibility is there. If I see here, how many poles and zeros forward? Nil. Right, that is even number. So where will the root locus exist on the real axis? Only between minus 2 and 0. Only between minus 2 and 0. Only between minus 2 and 0. So ye lijiye. Between minus 2 and 0, I'll draw that branch first of all. Ye lijiye. Right. So from minus 2, we have to go right. From the 0, we have to go left. Very obvious. If you are traveling on the same line, in the opposite direction, you are going to intersect. There will be some intersection point that can be calculated using breakaway. Breakaway मैंने आराम से discuss कर लिया. So I have not calculated the breakaway here. But dear, there will be some breakaway point. I have not calculated here, but there will be some breakaway point in between. Approximately रख लेते हैं this one. Right. After the breakaway, what will happen? They will go towards the conclusion. When you calculate breakaway, there is only one breakaway that is going to come. After that, they are going to go towards termination. Where is the termination this time? There is no asymptote. Whenever P and Z are equal, no asymptote. So termination is there towards the open loop poles, open loop zeros. Okay. But when a branch terminates at open loop 0, कैसे आएगा? How does it go and merge there? That is what we have calculated as angle of arrival. Huh? How a branch will arrive at the 0. How a particular branch will arrive at the 0. That is what we have calculated using the concept of angle of arrival. So first of all, let me put down that angle of arrival into the picture. How much is the angle of arrival? 225 निकाला था यहाँ से. Positive 225. Positive means anti-clockwise. 225 is 180 plus 45. 180 plus 45. This is 225, which was calculated as your angle of arrival. Similarly, if I go to the below one, okay, minus means now turn clockwise. Clockwise 225, so 180 plus 45. This is the 180 plus 45. This is minus 225, which is again one of your angle of arrival. Okay. So what I am now doing is, okay, I have my branch intersected at a breakaway point that I have not calculated here, but from this breakaway point, one of the branch will go and merge towards the zero such that the angle of arrival line looks like a tangent. Dhyan dena. The angle of arrival line should look like a tangent to the curve. Okay. This is what is the next merging. This is the root locus complete. This is the root locus complete with the angle of arrival. So the intent was angle of arrival. The intent of this question was angle of arrival. What is this? This is the breakaway point, which I have skipped for this question. You can calculate, you know, I have given you the technique. So let's focus on something new rather than calculating the breakaway point. Okay. Function is also very simple, very easily आपका breakaway point आ जाएगा. तो please do calculate it later on. ठीक है? Please do calculate it later on. In meanwhile, if somebody was very quick and already calculated, comment कर दो तो मैं लिख दूंगा. Otherwise, you calculate later on. ठीक है? Let's move ahead to the next then. Let us move ahead towards the next case then. Let us move ahead towards the next case. Okay, chalo. Alright guys, so before I take the next case and next question, as I was telling you, I will update the date. Most likely, this general aptitude session to make your entire revision complete, is going to come up most likely next Sunday, 15th January, save the date. Most likely 15th of January, next Sunday, save this date, a general aptitude. Most likely by Monday I will confirm you the date, but most likely it is the next Sunday, that is 15th of January, starting from morning. Okay. So this coming soon date exclusively for you guys I have revealed here. Acha, one more thing, we will share you the password, we will share you the PDF of the control session combined, because yesterday it was taken by me and Ashu Jhangra sir. Today Fanin sir will also join. Yesterday Fanin sir could not join, time ho chuka tha. So, you know, whatever we have taught, we will cover up, we will combine the PDF and we will share it to you, right, today. Both. Digital part 1, part 2 I have shared to you. Control combined share karunga main. My part, Ashu Jhangra sir part and Fanindra sir part. I will combine and share it to you, and the password of the PDF will be Locus. Root Locus part hai, the random password Locus. Please note down, the password is going to be everything in small, LOCUS Locus, and there is going to be one single PDF for both the parts combined, yesterday and today, including me, Ashu sir, Fanin sir, everything. Okay? Right, and this is the next Sunday activity. Most likely next Sunday, Monday tak main aur confirm kar dunga. Now come to this here. The characteristic equation of a control system is given to you. S square plus 5ks plus 9 equal to the 0. S square plus 5ks plus 9 equal to the 0. Okay, what is the root loci of the system? Tell me. What should be the root loci? Now, directly the GSHS is not given. Characteristic equation is given. Right, Telegram. PDF will be there in the Telegram. Okay, in my Telegram, Ashu sir's Telegram, Fanin sir Telegram, I'll share you my Telegram link, don't worry. I'll just share you my Telegram link. Just wait, है ना? I'll share you in some time. Don't worry. वो शायद log out हो गया है. Okay. Just don't worry, है ना? It has logged out. Yeah, tell me the answer for this by that time. This one. Chalo, tell me guys, anybody with the answer? The characteristic equation of a linear control system is given to you. So dhyan dena. What is given to you? The characteristic equation directly. S square plus 5 ks plus 9 equal to 0. You should always be writing this as 1 plus GSHS equal to the 0 format. Okay. 1 plus GSHS. So we'll just rearrange this, guys. s square plus 9 plus 5s into the k equal to 0. And when I divide by s square plus 9, I can see this equation as 1 plus k multiplied by 5s divided by s square plus 9 equal to 0. And this looks like your clear 1 plus GSHS equal to 0 format. Okay. 1 plus GSHS equal to 0 format. Okay. Now, what are the open loop poles? What are the open loop zeros that you can clearly check from here? I will call my GSHS equation as k 5s divided by the s square plus 9. So open loop zeros is at 0, 1. And open loop poles are conjugate s equal to plus minus j3. And there are 2 of them. Now, this is definitely wrong. Some option elimination. Root locus will start. The root locus will start from the open loop pole, not terminate. This is also wrong. Root locus should start from the open loop pole. Okay, so the possibilities, this is a MCQ question, so option elimination dekhenge. These two are the possibilities left. Now, there are two procedures. Either calculate the angle of departure, but usme thoda time lagega na. You can calculate angle of departure, I have told you, clear techniques, but usme time lagega na. What I can do? Existence on the real axis. Dekho. The root locus will exist on this section of real axis. Lekho, total number of poles and zeros 1 2 3 1 2 3 forward. ये तो odd number है, तो यहाँ exist होना चाहिए. But option number C says here it doesn't exist, and it exists here. So this is wrong. So correct answer is D. The correct answer is D. That's it. Very simple. Option elimination, you get your answer. Right? Your option elimination, you get your answer. Because what is the only thing that I have done here is the odd number criteria. Okay, we have the 0 at the origin and we have the poles on the plus J3. Sorry, this is the 0. We have the poles at plus minus J3, and according to the odd number criteria, the root locus should exist here, because here we have 3 forward poles and zeros. Here there is nil, so root locus should not exist there. That is why option number D is the only option left, and root locus will start from poles that we anyways know. So A and B are eliminated using that. Correct hai? Okay. Now quickly let me give you very shortly, the funnins are also will be waiting to come. So quickly let me tell you the complementary root locus steps. Okay, let me at least revise you. Complementary root locus kab aayega? Complementary root locus will come. It is like the root locus for k less than 0. Okay, for k less than 0, right? That means suppose some GSHS is given. GSHS is given k into some zeros divided by some poles, but with k less than 0, that is number one case. Or primarily, it is also defined as the root locus for positive feedback systems. Because for positive feedback system, what is the characteristic equation? For the positive feedback system, what is the characteristic equation? For the positive feedback system, the characteristic equation is 1 minus GSHS equal to 0. Right? So either the GSHS has the gain k which is negative, or either the GSHS, यहाँ पे k को positive लेंगे हम. Here, we will take the normal gain k, but we already put, because of the positive feedback system, we know the transfer function is GS upon 1 minus GSHS. Okay, so it automatically introduces the minus here, so that what is the procedure that is going to be changed? Any point lying on the complementary root locus will satisfy what? Will satisfy 1 minus GSHS equal to the 0. And that is why, dear, GSHS equal to 1. Complementary root locus koi dekhe, okay, it is the GSHS equal to the 1. So what is modulus of GSHS? Modulus of GSHS equal to the 1. Okay, but angle, since it's a positive real number this time, since it is the positive real number, it's lying on positive x-axis, the angle would be what? Right, what is the angle of positive real number? The angle would be 0, or kya bol sakte ho? Or 360, plus or minus 360, etc. So angle is like 360 or 720. So this time it's an even multiple of 180 degree. Right, k can be 0 also. यहाँ पे आपने k को 0 रखा तो 0 plus minus 360 degree, etc. This time it is the even multiple. This time it is the even multiple of 180. For the root locus, it is the odd multiple of 180. Pranit, you know, transportation lag the stability of transportation lag should be best handled by Bode plot technique. So next Nyquist Bode plot is also going to come up. So there you can talk about the transportation lag better. ठीक है, तो यहाँ पे आ जाते हैं dear. So it should be the even multiple of the 180 degree. It should be the even multiple of the 180 degree. So what are the steps of complementary root locus? Sir, only those steps which were related. See, derive तो हमने किया नहीं था. We don't have that much of derivation. Okay, the time for the derivation, but only those steps which came out of the angle GSHS property will be modified. Say for example, angle of asymptotes. All other steps, जैसे कि मैंने बोला 1, 2, 3, 4. These steps remain to be same. Whatever I am not writing same. Directly angle of asymptotes. Angle of asymptotes also, which was, let us write it in the regular form, 180 by n. Again do the same thing. Divide the 180 by n, but take the even multiples this time. Take this time the even multiples, not the odd multiple. This property is going to change. Take the even multiple of 180 by n. Right? Existence of root locus on the real axis. Existence of root locus on the real axis. Only change the steps I am telling. This time the root locus will exist on section of real axis. On the section of real axis where the forward poles and zeros is an even number. That criteria will also change. All odd criteria will change to even criteria. Forward poles and zeros should be even. अभी तक क्या देखते थे? Odd. Now forward poles and zeros should be what? Should be the even. Angle of departure, again, angle of departure is like 180 replaced by 0. Right? This is like what? This is 0 degree minus phi p minus phi z. Earlier it was 180 degree because root locus tha. The angle GSHS was 180 degree. But this is complementary root locus. GSHS is positive, real number. So 0 degree. 0 or 360, koi bhi le lo. For simplicity, let's better take the 0. So 0 minus phi p minus phi z is as simple as minus of phi p minus phi z. How to calculate phi p phi z? Sir, no change. Sir, no change. And similarly, angle of arrival. Minus of phi z minus phi p. It is the minus of phi z minus phi p. It is the minus of the phi z minus phi p. So these are the changes. I've just given you the revision of the formula. These are the changes that you can expect in the root locus, in the complementary root locus steps. Okay? In the complementary root locus steps. In the complementary root locus step. Chalo. Now sketch the root locus for this system. This is one important case and I'll directly tell you the shortcut for this. Chalo. Bol dijiye, what should be the answer for this? Yes. My voice was not audible because I was on mute. Now let's continue. Root locus for k upon s plus 1 whole cube. Now dear, we have already understood what are the steps. We have already understood what are the steps. Okay. Now let us not go with the detailed solution of this. This is an important case. What type of important case? What type of important case? I will write down this one separately. Whenever you are given GSHS equal to k divided by s plus a power m. Okay. There is only one pole which is repeated. There is only one pole which is repeated. Right. If I want to talk about the pole, if I want to talk about the open loop pole, s equal to minus a. Right. But only same location repeated m times. What? Repeated m times. अब इस पे कई क्वेश्चंस आते हैं कॉम्पिटिटिव एग्जाम में, गेट, ईएससी प्रीलिम्स, इवन इसरो एंड ऑल एग्जाम्स यू विल फाइंड दैट. ओके, s equal to minus a is the only pole, but that is repeated m times. The root locus for this problem. The root locus for this problem. Direct conclusion I am giving time save करने के लिए. And why direct conclusion important है? हर एक का direct conclusion याद नहीं रखते, but this one is important, right? Root locus will consist of only and only m straight lines. Only and only m straight lines. There will not be any curvature here. Root locus will consist of m straight lines starting from where? Starting at s equal to minus a. That itself is the centroid also. Starting at s equal to minus a at what angle? At asymptotic angles. Here. Starting at what angles? At asymptotic angles. At asymptotic angles. तो यहां पे ध्यान देते हैं. What are the open loop poles here, dear? What are the open loop poles? What are the open loop poles? S equal to minus 1, minus 1, minus 1. Minus 1, minus 1, minus 1. Acha, how many asymptotes will be there actually? Okay, there are 3 poles and there is no 0. So there are 3 asymptotes. Clear? For 3 asymptotes, do we know the angles? That is already sorted in our mind. 60, 180 and 300. What is the root locus for this? What is the root locus for this? ये लीजिए. As I told you, it is the form k upon s plus a power m. This is of the form k upon s plus a power m. This is of the form k upon s plus a power m. There is only one pole which is repeated, so there will be only 3. How many? 3 straight lines starting at minus 1 at these angles. There will be only 3 straight lines starting at minus 1, starting at the location of pole, at the angle of 60 degree. This is approx 60 degree, let's say. Okay, at symmetrically ये हो जाएगा 300 degree वाला and 180 degree. This is the root locus. Done. This one is the root locus. This one is the root locus. Clear? This one is the root locus. भाई, there was a question once. एक बार कुछ ऐसा question था. GSHS equal to the K by S square. There was a question of this kind. In GATE as well as ISRO, दोनों में ये वाला question पूछा गया है. K upon S square. What will be the root locus for K upon S square? Hey, so the only open loop poles is S equal to 0 but repeated. Repeated, right? So how many asymptotes will be there? 2 asymptotes. So what will be the theta? 90 and 180. Because there is only one pole location repeated, so we know the root locus nature. है ना? We know the root locus. You know the root locus nature. I'm just going to draw that. So these are quick and easy procedures. Okay. The root locus will start from minus a, that is 0. The root locus will start from pole 1 at the 90 degree. 90 degree is vertically upwards, positive y axis. Next is 180 क्यों लिख दिया? I'm sorry. This is 270. And 270 is vertically downwards. 90, 90, 90. 270 is negative y axis actually. Anti-clockwise 270 degree. Okay. One of the branch is going towards the top, another one coming towards the bottom. That's it. Okay. And this is the location of the poles. That is origin. Done hai? Done hai? Now, why this method I've introduced for quick calculation? Let us see one good question from here. Let us see one good question from here. Consider a system having GSHS equal to K upon S plus 2 power N. What is the range of K for the system to be stable? Normally, what is the method striking with this question? Range of K for the system to be stable. For most of the students, normally the method that will strike, na, Normally the method that will strike is RH. Yes, Shakti, correct. The range of K for stability, RH. अच्छा चलो, RH के लिए characteristic equation लिखेंगे. When you go to write down the characteristic equation, it will be 1 plus K divided by S plus 2 की power 10 equal to 0, and it will be S plus 2 power 10 plus K equal to 0. It is going to be very lengthy by RH for two reasons. It is going to be very lengthy by RH here. Right. Why lengthy? Because number one, S plus 2 power 10, you will expand using binomial expansion. First of all, bhai, you need the complete polynomial equation. You need the binomial expansion. Okay. So for two reasons, it is lengthy. Number one, to binomial mein jana padega. That also you can do, but it will take time. I am not telling difficult. I am telling lengthy. Difficult nahi bola hai. I am telling lengthy. So number one, you need the binomial expansion. Chalo. Then next step, you expand using binomial, you get a S power 10 equation. There will be a RH of how many rows? S power 10. So S power 10 to S power 0, 11 rows will be there. Okay, there will be a RH. There will be a route array containing 11 rows. It's not 4, 5, 6. It's 11 rows. So think about the calculation. Again, I repeat, this is not difficult, but this is going to be very lengthy. So for such cases, root locus, the approximations can be applied. Approximation using the root locus. As you know, root locus have been sketched using approximation technique only. Right? It's not like that this is going to be purely a straight line, but approximated by straight line. Approximated by straight line, and it works good. It works good. ठीक है, तो यहां पे इसका रूट लोकस पे चले जाते हैं. राइट, यहां पे इसके रूट लोकस पे चले जाते हैं. What is going to be the root locus and how to assess the range of K for stability from there? What is going to be its root locus? Everybody just let me draw here first of all. S plus 2 की power 10. S plus 2 की power 10. So this is the pole, only pole at -2, but that is repeated 10 times. So I can directly use the technique of root locus. S equal to minus a repeated 10 times. So there will be only 10 straight lines starting from here with what asymptotes angle? With what asymptote angle? तो asymptote के angle कैसे निकालेंगे? What will be the asymptote angle? Theta. 2k plus 1. Odd multiple. We know the formula. Odd multiple of 180 by n. कितने asymptotes? 10 asymptotes. Right. So it is the odd multiple of 18. So 18 degree. Odd multiples of 18. So 18 threes are 54. 18 into 5, 90 degree, etc., etc., etc. Till the last one, that is going to be 18 into 9. How many asymptotes you have? You have 10 asymptotes, correct? Right. और उसको symmetry से अगर आप लिखोगे, so that can also be ठीक है ना? Yeah, so one by one you will take this asymptotes. S plus 2 की power 10 है, right? तो 18, 54, 90, etc. Correct है. These are the correct angles that is going to come. Now using these angles, let me just draw the asymptotes here. Let me draw that asymptotes क्या पूरा root locus ही आ जाएगा. First is at the 18 degree. First is what? 18 degree. Smaller angle. Next will be, अच्छा, third one 90 पे, ये भी बता दिया. Let's say this is the third one, 90 degree. Next is one of them at 54 degree. One of them at the 54 degree. And etc., 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 dear. This one is 18. This one is 54 degree. This one is 90 degree. And then there will be etc., 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 multiple branches. Due to symmetry, there will be one more branch here. Root locus is always symmetric, na? So there will be one more branch which is at 18 degree clockwise. Which will be at the 18 degree clockwise. ठीक है? चलो done है. Done. Now, question is still unclear. What is the range of K for the system to be stable? What is the range of K for the system to be stable? System becomes unstable whenever the root locus go into the RHP. Whenever the root locus goes into the RHP. Can I find the value of K here? Can I find the value of K here? इस triangle को थोड़ा सा separate कर लोगे ना. Let's say This is as always origin. This is my pole P, right? And let's say this is some point Q. Let us say this is some point Q. The smallest angle is 18 degree. This is O, this is P, this is Q, right? This base is equal to 2. Can you find out the value of OQ? Can you find out the value of OQ, right? Yes. How you can find out? By the tan theta. Opposite side is divided by the base 2. So what is the value of OQ? It is twice of tan 18 degree. It is twice of tan 18 degree. And OQ is a point on root locus. It is point on root locus. Achha, what is the value of 2 tan 18 degree? 0.65 nearly. It is a point on root locus, right? So what I will do at this point, mod GSHS will be how much? At this point, mod GSHS will be the 1. At this point, mod GSHS equal to 1. So modulus of K divided by S plus 2 ki power 10. 0.65 plus 2 raised to the power 10 at this point should be equal to 1. Mod GSHS equal to 1. So sir, what should be the value of K here? That is 2 point, this was 0.65 only, correct? S plus 2 hai? Yeah, perfect. S plus 2. S is equal to, once again, let me just check the calculations for a moment. Perfect. This is 0.65 and this one is a point lying on the root locus. Oh, I'm so sorry. I'm so sorry. So this is OQ. What is the point lying on the root locus? Yeah, sorry. थोड़ा time खत्म हो रहा है ना, इसलिए जल्दी में कर दिया. S is equal to J 0.65. S is equal to J 0.65 dear. Why? This is a point on the y-axis, na? So what is this point? This is J 0.65. This is not the real axis point. This is J 0.65. So यहाँ पे हम J भी रख देंगे. And then we have to take the mod. Okay. So J 0.65 plus 2 raised to the power 10. Okay. Then mod of complex number, you know how to take. Right. This is going to be 2 square plus 0.65. What has happened? Plus 0.65 square whole under root. This is 1 modulus raised to what? Power 10. Let's calculate this number. Sorry, hai na? Let's calculate this number. This is 1691.76. K is approximately 1692. Approximately likh liya 1692. Now, if you take the value of K slightly greater than this, what will happen? If you take the value of K slightly greater than this branch enters the root locus. This branch enters the RHP. System is unstable. So what is my answer? 0 less than K less than 1692 is the range of K for the system to be stable. Then quickly I'll tell you, sir, you might be having a doubt. I'll tell you, some of you might be having the doubt. Sir, why only this point? Why not this point R? Why only first line is considered? If you have the doubt, listen to me. If you are clear, very good. Why not the next point? Because next point corresponds to a higher angle, 54 degree. So this height is going to be more. This height is going to be more. Yeah, that's what Nirmal, wahi main bata raha hu. This height is going to be more. And if this height is more, right, this is 0.65 na. Ye 2 tan 54 degree aayega. Nikal lo chalo. This much can be done in just 5 seconds. So 2 i's of tan 54 degree. This is going to be 2.75. S is J 2.75. So of course, if S value is higher, the K value will be higher. K same nahi hoga, right? If you place this value higher, the K value will be much higher because of the power 10. It's going to be amplified like anything. It's going to be amplified like anything, right? So suppose kitna aaya? Just to clear your doubt, I will answer this. This is somewhere around 2 lakhs. Bhai sahab, listen, this is somewhere around 2 lakhs, around greater than 2 lakhs. So dear, if the K becomes more than 1692, listen to me. If the K becomes more than 1692, ye to safe hai. This will be somewhere here. To reach here, I need K 2 lakh. But if K becomes more than 1692, the second branch is safe, but this branch goes into the RHP. And what is the condition of instability? Even if one branch in RHP system is unstable, na? So that is why we need to check with the lower value of k. आ गई बात समझ में? We need to check what? We need to check with the lower value of k. That higher value is not required. Is not required. ठीक है? Done है? Cool है? चलो guys. So with this, thank you. I'll just quickly transfer because there are very important topics left. That is the Nyquist, Bode, gain margin, phase margin, all of them left. Just transfer this session immediately to Fun-Insert. I hope you are all refreshed. Right now, we don't think there is any time for break or you need the break. You are into online world. Even if you need to eat or drink something, you can carry it with you. Okay, you don't have to go somewhere. It's not an offline class. So even if you need any refreshment, apne saath le lo, have tea, coffee, water, juice, anything you want, and let the show continue, right? ठीक है. If बहुत ज़्यादा कभी लंबा हो, you let us know the break. But right now, I think it's time to straight away continue.
Hello, welcome to India's most comprehensive e-learning platform, BYJU'S Exam Prep. And also, special welcome to every one of you and very good afternoon to all the students. Wow, great. So one second, just give me 1 second. Yes. Good afternoon, good afternoon. Ravi Teja, it is good afternoon, it's not good morning. Fine. Anyway, so I hope you guys have fantastic session, morning session by Rakesh sir. And I was also seeing the concepts of root locus. The way he has taken the last two problems were outstanding, right? So probably you got ample amount of knowledge in the root locus, and let me continue the same harmony in the frequency response plots, because students used to say that I'm damn good in frequency response plots. So we shared such that the frequency response plots come to me, and I may handle at least 2 hours minimum. So I request to have great patience till the end, then only you will be able to correlate everything and get a solid understanding. Because I always say this, control system as well as circuit theory, these are the 2 subjects in which you can find the linking between several concepts and you will enjoy a lot, right? So Ashok, good afternoon. Satyasri, good afternoon. Hema Gottapu, good afternoon. And Nirmal Gupta, good afternoon. Okay, well, so shall we start? All of you are energetic or not? So please mention in the comment section, give me a big thumbs up so that we can start right immediately without any further delay. Well, so as you all know, currently we are in the marathon session. As you all know, we have started taking the sessions from the 4th of January. Of course, the introduction was given almost on 3rd of the January, right? So this might be a third core subjects, in fact common subject for EC, electrical and instrumentation students. We're done with the circuit theory. We have completed all the topics of circuit theory. Currently we are discussing both one side analog electronics is going on, and right now control system is also going on. Hope you guys are really enjoying the marathon session. So please let me know in the comment section, are you really enjoying the marathon session or not? Is it really adding value in your great preparation or not? So Nirmal is saying yes. Okay, fine. Right. So these are my credentials. Of course, the old students already know about me. For the new students, you all can see myself, Panindra, all put together. I have an experience of 11+ years in teaching industry. And coming to the expertise, so I teach control system, circuit theory and industrial instrumentation. Of course, all these 3 subjects are not there for every student, but control system and circuit theory are common for EC and electrical students. Right, Raviteja is excited. So let's keep the same excitement throughout my discussion also. It will be around 2 hours to 2.5 hours. Trust me, you will learn many things, right? It's not like, hard and earn rule, like if I discuss one question, I will be only in that question. So those students who are attending my lectures from long back, they might be knowing, if I take one question, I will going to look at all other dimensions of the question, and that is the best way to discuss also, correct? So what we mainly cover in today's session, it starts with the basics of frequency response analysis. Second, we will going to discuss about one of the very important topic in the GATE syllabus, from where you will definitely get a question. Okay, So that is frequency response plots. That one among that is Bode plot and polar plot also we will discuss. Nyquist plot I will give shortcut today, and gain margin and phase margin, stability from frequency response plots, and at last we are also going to discuss about compensators and controllers. Guys, I would like to tell one important point. I have been provided 2 to 2.5 hours session, so I require a lot of attention and cooperation from you. Keep the calculator and pen and paper with you. Whenever I ask any question or calculation, please respond very fast. Now tell me, are you guys ready? Are you guys ready? So Ganesh, Repalle, yes sir, yes. Mahalashmi, please let me know, every one of you, Krishna Veni, Nirmal Kumar Gupta, Mahalashmi, every one of you. Are you guys ready to take the session on frequency response plot? Yes or no? So as I said, the first topic is basics of frequency response analysis. So let me straight away go to revision part. Okay. So first let me give a simple revision, because you might have studied control system long back. Let me go with respect to revision first. Once I made the solid revision, then we'll also discuss about the questions. Again from the questions I will going to revise the concepts. So it's like a loop. Right? So by the end of the whole discussion, your revision will be completed, your shortcuts will be completed, questions also will be completed. I feel that is the best thing, right? So, well, the first thing is frequency response analysis. What do you mean by frequency response of a system? Suppose let us say we have a system and its transfer function is g of s. Don't ask me a question whether this is an open loop system or closed loop system. Basically, this is a system. If you don't like g of s, you can take p of s, you can take t of s, you can take m of s, anything what nonsense you want to take, you can take, nobody will going to stop you, right? So the frequency response means the input signal must be a sinusoidal signal, number one, right? So that is likewise how you are going to apply step input and ramp input, parabolic input. Similarly, we will also try to apply sinusoidal input. Do you know why we are going to apply sinusoidal input? Why we are going to apply sinusoidal input? Any one of you? I love this question. Let me see how many of you will answer this question. Why we will apply sinusoidal signal? So in practical situation, whatever the signal you may have, right? So that particular signal can be splitted as a summation of sinusoidal and cosinusoidal signal. This is what called Fourier series, correct? So that means if I give any random signal in general, let's say a noise signal, let's say this might be an input signal. Clear? This might be an input signal. What signals and system says is, or what basic signal theory says is, this particular input signal can be divided into sum of sinusoidal signal plus cosinusoidal signals, correct? So that means you don't know what is the mathematical expression for this input signal, but when you split that, you will get a sinusoidal component with a different harmonics. Therefore, it is better to know the sinusoidal response of the system for a single frequency, and then we can generalize and make the response for this particular input signal. Clear? That is the beauty of this. I hope you understood. Very good, Dinesh. Excellent. Outstanding answer. I was expecting this answer. Lovely, guys. So please maintain the same rhythm. You and me both, let us enjoy together. Okay, suppose if I say x of t is equal to a into sine omega, so let us say a into sine omega I into t plus phi, that is phase in. Clear? It is the most popular question. I also don't know why IIT is so crazy about this format of the question. Every year, more or less, I am finding this question either in EC paper or electrical paper or instrumentation paper. Sometimes all three also. Okay. So let's complete this one. Very good, Hemant. Excellent, excellent. So x of t is equal to a sine omega I into t. People do say that this is the amplitude of the input and frequency of the input signal, phase of the input signal. Clear? Now, most important thing is, what is y of t? Y of t could be written at steady state. So because when you apply the sinusoidal input also, depending upon the system, we will going to get a transient state. But at steady state, we will be having some amplitude b into sine, but the same frequency will be there. That means the output and input both will going to have the same frequency. At the same time, we will be having the different phase here. Clear? So that means the magnitude and phase of the system will going to change. Now it is a very important question from you, right? So those students who already attended my classes, all these things are cakewalk to you, but it is my responsibility to revise for the new students. So please do have some patience. The old students, please do have some patience. We will rock today. Okay, that is my assurance. So the amplitude of the output. So we can say the amplitude of output B is equals to amplitude of the input into at the same time the magnitude of the system. How do we get the magnitude of the system? Modulus of g of j omega, right? Sorry, I am extremely sorry. This is going to be modulus of g of j omega. Raghuram, how are you? I am not seeing a message from you. Raghu, are you there in the session? So modulus of g of j omega, and of course omega must be at omega I radian per second, correct? So and moving ahead, the output phase of the system could be written as input phase here, correct? So input phase is there, that is phi I, and additional to that we do have another phase here, that is g of j omega. As I said, again omega must be equal to omega I radian per second. Now my question is, all of you think logically and tell me, the amplitude of the output depends on dash. Everyone must answer in the comment section. Comment section should blast today. So please respond very wisely in the comment section. So amplitude of the output depends on what? Amplitude of the output depends on the amplitude of the input, right? And the magnitude of the system at that operating frequency of the input signal, correct? So the amplitude of the output depends on the amplitude of the input and the magnitude of the system at the operating frequency. Now it's not guaranteed that we will apply same frequency every time. You may apply 5 radian per second, I may apply 10 radians per second, and some other Rakesh sir might apply 20 radians per second. So for every frequency, we can't assure that the same value you are going to get here, correct or not? So that means when I change the frequency here, then definitely this value will change. When this value changes, then the magnitude of the output also will going to change. Why all the students should respond in the comment section, okay? The way how you are responding, the more you respond, the more energy I will get and the more concepts you will get, okay? So if I am excited from the ground level, valency band to conduction band, then it goes for more conduction of the knowledge. Naturally, you will be enlightened, right? So please answer to every question here. So when the input frequency changes, the magnitude changes, then the amplitude of the output will going to change. Simple. Similarly, if you look at, so the phase also depends on the frequency. The moment when you change the frequency, the phase will change. When the phase of the system changes, then the output phase will going to change, correct? Output phase will going to change. Now, can I say one thing clearly? When I vary the value of frequency quite logically, omega I, right, versus modulus of system, that is magnitude of g of j omega, and if I know what is the way how these two are getting or these two are related, why I need to know this one? Because if you know this relation and if you know this relation, then you will be understanding what happens to your magnitude with respect to, amplitude of the output with respect to the frequency. If you know what is this relation, then you will be understanding how the phase of the output signal is changing with respect to frequency. Ultimately, we will be knowing what happens to the output with respect to time at steady state. So as we are calculating the response of the system with respect to time by applying the sinusoidal input signal of different frequency, we call this as a frequency response analysis. Clear? So I hope I have given a beautiful introduction in just a matter of 5-10 minutes, right? So by varying the input signal frequency, when you understand how the magnitude of the system and the phase of the system changes, then you will be able to understand the response of the system at steady state. Clear? Ultimately, our objective is not to know, please try to remember this point. Our ultimate objective is not to know these things. Our ultimate objective is to calculate the amplitude of output and phase of the output signal. But to get these values, you must know this and this. Clear? And how do we learn this one? So basically, there are some representations for this variation. There are some plots which show the variation between the frequency versus magnitude, that is first one, and the frequency versus phase. And those plots which shows the variation between the frequency and magnitude, frequency and phase, they are called as a frequency response plots. Clear? So I think I have come to the point now, right? Frequency response plot. Now you tell me why we require frequency response plots. Any one of you? Everyone must answer. So up to here, is it everything is clear? Or any doubts, please put it in the comment section. So frequency response plots are useful to understand how the magnitude and phase of the system changes with respect to frequency. If you know that, then you will be knowing that how the amplitude and phase of the output will change. And that is what actually we are expecting, correct? So now without waiting further, let me go with the first frequency domain specifications and some of the formulas. As I promised you, we will go for a quick and intense revision along with the questions also. Clear? Right. Yes. Now the first thing is not only Bode plot, the idea of all frequency response plot is more or less showing how the magnitude and phase changes with respect to frequency. Frequency means generally it should be input signal frequency. Clear? So now moving ahead, suppose let us say I have some function like g of s into g of s is equal to you can take like omega n square divided by s square plus 2 zeta omega n into s plus omega n square. This is a standard second order transfer function, correct? So if I get the magnitude, how do we get the magnitude here? First replace s is equal to j omega. If you replace s is equal to j omega, then you will be getting like omega n square, and here minus omega square you will be getting plus 2j into zeta omega n into omega. Of course you will be having omega n square here. Take out the omega n square outside, then you will be having modulus of g of j omega. In fact, it will become like 1 minus omega divided by omega n all the way whole square, and then plus additional to that we will be having 2 zeta and omega by omega n. This is considered to be, honestly speaking, this is a function. But if you want the magnitude, right? So if you want the magnitude, how do we get the magnitude of this one? Just look at that. This is the magnitude of the system, and some people do call this as a m of j omega. So m of j omega or magnitude, both are same. That is equal to, how do we write this one? So it is simply a denominator is a complex number, real part and imaginary part is there. So therefore I could say under root of 1 minus omega by omega n, right, whole square, and we can square once again here, and 4 zeta square and omega by omega n square. Clear? So this is considered as a magnitude of the second order transfer function. Now naturally many students, they ask a question, fine sir, all this stays, but how do we sketch the plot, frequency response plot? The basic idea is so simple. What I told you, after getting the magnitude, just change the frequency and then substitute the value of frequency and get the magnitude here. So please try to see in this magnitude form, if you substitute, or there is a frequency at which you will be seeing the maximum amount of the magnitude. Clear? I repeat, there is a value of omega where we will be getting the more value of the magnitude or more value of the response, and that frequency is considered as a resonance frequency. In short, we call this as omega r equals to omega n into under root of 1 minus 2 zeta square. Now can anybody say, for undamped system, everyone be fast. I'm not seeing the response from many of the students here. Krishnaveni is not messaging, Ravi Teja is not messaging, Payash Kumari and Ravi Shankar, all of you be active in the comment section. Suppose if it is undamped system, what is the value of, what is the relation between the resonant frequency and natural frequency? I repeat the question. If it is an undamped system, what is the relation between natural frequency and resonant frequency? Everyone, undamped system. Undamped system means you are not giving any control, right? You are not giving any control, and the system also doesn't have any self-control. Then it will always oscillate, correct? If it is always oscillating means naturally the damping is 0 here. So if the damping is 0, straight away I can say omega r is equal to omega n. Clear? Clear? So that means, by the way, when you feel that resonance is coming at the natural frequency of the system, that means that particular system is in oscillation, or the step response or the impulse response of that system will be oscillatory. So it is unstable system. Clear? So I hope you understood that logic behind that. So generally whenever we use RLC circuit in resonance, have you seen every time when we take RLC circuit in circuit theory and operate at resonance? When you operate at resonance, then you will understand that at resonance omega r and the natural frequency will become same for unstable system. Clear? Very good, lovely. Mahalashmi and Payak Kumar, Abhishek, very good, outstanding guys, nice. Now fine, it is the frequency at which we observe the maximum magnitude, but what is the value of this magnitude? That is also important. So the magnitude can be written as, in fact this is called as a resonant peak. So let me write down here, this is called as a resonant peak. The derivations of all these things were clearly explained in recorded lectures as well as regular classes. So this is called as a resonant frequency. This is called as a resonant frequency, of course, resonant frequency, and this is called as a resonant peak. Clear? And where mu r, technically mu r is considered as a normalized frequency, which is equal to omega divided by omega n, omega r divided by omega n. Please try to remember everything clearly. Omega r divided by omega n. I hope I have conveyed the message very clearly. Moving ahead, there is one more important specification, frequency domain specification, that is bandwidth. Clear? So the bandwidth is all the way can be found like this. Though I know the bandwidth is relatively a big formula, but usually I don't encourage anyone to remember the formula. But of course you cannot derive this during the examination. So try to solve at least 2 to 3 questions on this formula, then you will be able to remember. Rest of everything is simple. See, what is the, I will tell you a shortcut to remember this formula. What is the damped frequency formula? Omega d is equal to omega n into 1 minus zeta square. Correct? This, every one of you know this. Whoever are preparing for control system seriously for GATE examination, every one of you know this. Now my suggestion is, if you already know this, just remember like this, just twice this value inside the bracket, that is 2 zeta square. Then you will going to get resonant frequency. Clear? Like that, you please remember, it's easy. Okay, so it is just only for remembering purpose, there is no concept involved in this. Okay, I hope I have conveyed the message clearly. Now let me go one step ahead, right, and discuss about the magnitude plots. Whenever I say magnitude plot or frequency response plot, there are so many frequency response plots are there, starting from the Bode plot and polar plot and Nyquist plot. When it comes to Bode plot, okay, there are 2 plots are there in Bode especially. What are those 2 plots? Any one of you? Every one of you, please respond in the comment section. The first one is the magnitude plot. Of course, if you are evaluating the closed loop system stability, wait one second. Second one is phase plot. Clear? So basically phase plot and magnitude plot can be drawn for any function. You can take g of s and draw the magnitude plot and phase plot. You can take h of s and draw the magnitude plot and phase plot. But in general, being a control engineer, for which function we will draw the magnitude plot and phase plot, whether we will draw for g of s alone or h of s alone. All of you please respond in the comment section. Whether we do, sir, I am Payesh. Oh, okay. Kumari, oh, sorry. Right, thank you for notifying me. So whether we will draw the magnitude plot for only g of s or only for h of s. Any answer? Any answer from your side? I want to know. Right? Guys, are you able to see the video properly? Please respond in the comment section. I am looking like it is looking blur to me. Little bit. Image अच्छा है आपका? So एक बार please respond in the comment section. Both audio and video are clear to you or not? Guys? Every one of you please respond. Raghu and Shivashankar. Yes. Oh, okay, fine. Then fine. Nice. So G of S is technically open loop system, right? H of S is the feedback function. So, but both of these two are frequency dependent functions. You can draw Bode plot or polar plot or any nonsense plot for G of S. Similarly, you can draw even for H of S also. But being a control engineer, what is important for us is G of S into H of S. Please remember this point. Clear? G of S into H of S. I am not denying that you cannot draw this for this. We can draw individually for both of this, but what we are interested in G of S into H of S. Why? Because if you know how G of S into H of S is changing, then I will be understanding how the loop gain is changing, and then I will add 1 plus this. Then we will understand how characteristic equation as a whole it is changing. So if you want to know how the characteristic equation is changing with respect to frequency, first you must know how G of S into H of S is changing with respect to frequency. That is the reason why we are always interested to go for G of S into H of S to understand the stability of the closed loop system. So hereafter, if I say magnitude plot means, try to keep in the mind and fix magnitude in the sense that is modulus of g of j omega, so m of j omega. In fact, we call that as the modulus of g of j omega into h of j omega. Hope you got the point here, right? So similarly, here what is going to be the phase? So the phase would be written as phi, and this would be written as phase of g of j omega, h of j omega here. Simple logic, clear? Right, now excellent. So first thing is, when I mention m of j omega in dB, it means that modulus of, let me write down m of j omega in dB. Technically, it is actually nothing but, so 20 logarithmic of, let me write down 20 logarithmic of modulus of g of j omega and h of j omega. Simple. And how that is varying with respect to frequency, though I mentioned it as log of omega, basically it means that it is on the logarithmic graph. It is on the logarithmic graph. Now, if I have some value here as m2 and this value as m1 here, clear, m1. May I know what is the slope of this line now? Now the slope of this line, so please see here, slope would be, this calculation is very, very important. So please see, suppose from here to here, okay, here to here, I want to get the slope of this line. I want to know what is the slope. How do we get the slope here, right? m2, y2 minus y1, y2 minus y1 means m2 minus m1, specifically divided by logarithmic of omega 2, log omega 2 minus log omega 1, clear? So though it is mentioning like omega 2 and omega 1, when you are taking the slope, as you are on the logarithmic scale, you must take log omega 2 minus log omega 1, clear? Excellent, Raghuram, outstanding, right? So now I will be asking a simple question. Suppose if I say omega 2 is equal to 10 times of omega 1, okay, and time being, let me take, this is equal to 40 and this is equal to 20, clear? Intentionally I am taking 40 and 20. Then how does it will become? 40 minus 20, everyone must respond in the comment section. 40 minus 20, and here it would be like logarithmic of omega 2 divided by omega 1. Now only I told you that omega 2 is equal to 10 times of omega 1. Correct, correct. Correct, Raghuram, very much correct. So 10 log of omega 2 divided by omega 1. How do we write this one? Omega 2, just now I told you that omega 2 can be written here as 10 times of omega 1. Then omega 1 will get cancelled, and all the way it will become like 20 dB per decade, clear? So we call this as per decade or per decay, whatever it may be, 20 dB per decade, clear? So basically decay means it is 10 times more. Omega 2 should be more than 10 times more than omega 1, and this is per decade. As I said, this is 1 decade. So let me say 1 decade, and of course omega 2 is equal to 2 times of omega 1 twice, then it is considered as 1 octave, clear? So is it clear to every one of you? In fact, I know most of you know this, but as I said, it is a process of revision, so it's my responsibility to revise these things. That's why I'm revising. Within 5 to 10 minutes maximum we will go into the questions, okay, right? So let's get into the some of the other four important what do you say, like thumb rules of the Bode plot. Suppose let us say we have g of s into h of s equal to, one second, g of s into h of s, one second, g of s into h of s for time being, right? G of s into h of s equals to some k by s is there, right? So that means we have only pole, right? So see, the magnitude plot of pole 0 at pole or 0 at origin will not start from omega is equal to 0. It starts from very less frequency omega 0.1 or 0.01, any other value of omega apart from 0. So this point is very, very important. Even if you have function like this, or even if you have like k by s square, or even if you have something like k into s, or even if you have like k into s cube, clear? So if you see in these two functions, and if you draw the plot, magnitude plot, you can keep omega log omega here, but it will not start. Usually its value, initial value will be 0.01, 0.1, something like that. So that means whenever the plot is not starting from 0, there is a chance that either there might be a pole or there might be a 0. Then how do we differentiate pole and 0, right? So then in a simple language I will tell you, suppose if it is the decreasing slope, right, then it is the indication of pole. Decreasing slope is always indication of the pole. Suppose if it is the increasing slope, then it is the indication of zeros. Clear? It is the indication of zeros. I hope it's clear to every one of you. Decreasing slope, always it means that there is a possibility to have a pole. Increasing slope, always there is a possibility to have a zero. Clear? So I hope you understood. But how many poles and how many zeros are there? That I will explain one by one. So please have patience for some time and see here. Clear? So the second point is the magnitude plot. Look at that. Magnitude plot of the poles at origin will be minus 20 dB per decay, and it will have a phase of minus 90 n degrees. And magnitude plot of zeros of order n at origin will have 20 n dB per decay, and it will have a phase of 90 n here. Clear? So these thumb rules are very important, and every time, see, I have seen in my experience there are some gate questions which are directly on the thumb rules. Directly on the thumb rules. Now I will give one by one question to everyone, such as Sri, Ashok, Raghuram, Mahalakshmi, and Janani, and Hemant, Sonali. Every one of you please answer here. Suppose, let us say I have a plot like this. Okay, I have a logarithmic of omega, otherwise people will cry here. So let me make magnitude here. So m of j omega. Really, listen carefully. Okay, don't be hurry, don't be tensed also. Be relaxed and happily. So suppose, let us say 0.01, and I am saying here 0.1, and I am saying here like 1.0. So let me say something like this. Clear? So it is just like that. Okay, 0.01 and this one. And for time being, let me tell you one simple logic here. You started here, okay, and it is coming just like that. Clear? So first of all, tell me, this is a pole or zero representation. Pole or zero. What should I take for g of s now? This represents g of s into h of s what? Fast guys, this much of time you should not take it. Okay, so let me take k, right? So what should I say? Pole or zero? Everyone. So slowly we will construct more and more things here. So please listen. So it is a representation of pole. Very good. Excellent. Very good. So first keep pole here, and then look at what is the order of that pole. Order of that pole. How we can define the order of the pole? First of all, you need to calculate the slope. Okay, you should calculate the slope. What is the slope of this one? So to know the slope of this, let me take here, for example, 40 dB. Okay, this is anyway magnitude in dB. So it is a 40 dB. So it is a 40 dB, and this might be 0 dB. Let us take 40 dB here and 0 dB here. Right? So now tell me what is the slope here, right? Slope decreasing means pole. Very good. So here you see 40 dB is the decrease, correct? 40 dB is decreasing. Nobody can deny this. 40 dB is decreasing. But how much the frequency is increasing? Frequency is increasing by how much? 0.01 से 0.1 होगा, right? So हो गया. So 0.01 से 0.1 हो गया. So how many times it is increased? 0.01 should be multiplied 10 times. Then only we will get 0.1. Correct? Then only we will get 0.1. That means it is considered as one decay. Clear? This is considered as one decay here. Correct? One decay. Right? So that means 40 dB is the decrease in the slope per one decay. So therefore, we write the slope here as 40 dB is decreasing per decay, but it is decreasing. Decreasing means we will indicate minus. Clear? Minus 40 dB per decay is considered as a slope there. Clear? Slope. Now come back here. Minus means this one. So see here, whenever you have a plot of poles at origin, the slope will be minus 20 n dB per decay. Now you have minus 40. How can I write minus 40? Minus 40 could be written as minus 20 into 2 dB per decade. So that means what does it mean? N value is equal to 2. N value is equal to 2. Correct? N value is equal to 2. That means there are two poles at origin. Clear? There are two poles at origin. I hope you understood this very clearly and logically. Now I will ask one simple question to every one of you. Fatafat, look at this and answer to me. Okay? So just I will ask one more question because I don't satisfy with this, because I feel everyone knows this, most of the students, and those who attended my classes, this is like cakewalk to them. Okay? So now let me ask a simple question. Right? So one second. Border plot you can play like anything. So let us take 10 here. Okay, 10 here, and now here we do have maybe like 80 dB, 80 dB, minus 80 dB, and it's increasing like this, right? Now be slow and tell me whether do you have 0 or pole. First, fatapat tell me, pole or 0 first. Just tell me pole or 0 first. Later we will identify what is the order, but first let me know whether this is pole or 0. Guys, fast. I don't know why it is looking so blurred to me, but you people are saying it's very good. So let's see, very good. So this is 0. So k into s. But now the question will come, what must be the value of n? S power n kitna hai idhar, right? So because it is an increase in slope, you understood that there is a 0 at origin. Fine. But what is the order of that? That is important. The order would be calculated only after knowing the slope. How do we evaluate the slope here? So 0.01 to 10. So first of all, you see 0.01 to 10. How many decades this one? How many decades this is? Guys, how many decades this is? 0.01 to 10. So now be clear about that. 0.01 to next decade. After one decade, it will become 0.1. Correct? And then again after one more decade, it will become 1. Right? And one more decade, it will going to become 10 here. Clear? So technically speaking, 1, 2, 3. Right? 1, 2, 3. We'll do one thing. Let me take 100 here. So then one more decade, it will going to become 100 here. Correct? So one more decade, it will going to become 1. 0.01 to 0.1, it is 1 decade. 0.1 to 1, that is 2 decades. 1 to 10, 3 decades. And 10 to 100, 4 decades are there. Correct? 4 decades are there. Right? So what should I say now? When we have 4 decades, then 80 dB is a reduction, or 80 dB is a gain. Because now minus 80 dB, you all the way reach it to 0 dB. Minus 80 dB, you reach it to 0 dB. What does it mean? You have improved your gain. All the way from minus 80 you came to 0, means your gain is positively added 80 dB, right? So therefore this slope could be written as 80 dB by 4 decades. Clear? 4 decades. And that technically, what is the value? 80 dB for 4 decades. Technically this value will be equal to 20 dB per decade. Correct? So let me say here 20 dB per decade here. That's it. 20 dB per decade is a positive, and therefore we can say this n value is equal to 1. Therefore it is equal to k into s. Clear? So that is what exactly it was saying. But whatever, even the previous example and this example, in both the examples, one thing it is common that the frequency is not starting from omega is equal to 0. It started from 0.01. It need not to from 0.01. Even sometimes it starts from 0.2 also. Clear? 0.2 also. Please note down this point clearly, right? After some time, don't ask me a question, sir, you said like 0.1. In the exam they have given, 0.2. I said like it won't start from 0. It doesn't mean that it is 0.01 or 0.02. Clear? So now let's move on to the next page, right? Suppose if you have a magnitude plot of a pole of order n at corner frequency will change the slope by minus 20 n dB per decade. These are real poles. Suppose let us say g of s into h of s, that is equal to 1 divided by 1 plus 2s. Clear? 1 divided by 1 plus 2s. Right? So now in this case, what is the pole here? Any one of you, what is the pole? Raghuram, what happened? What is the pole of this one? So the pole of these two will be equal to minus 1 by 2. Correct? Minus 1 by 2. But we don't take minus 1 by 2 because we will be only taking the magnitude of the pole here. So let us look at this one. 1 by 2 here, right? So 1 by 2, and this 1 by 2 technically, or else let me take 1 by 2, that we call this as a corner frequency. Clear? Corner frequency which is equal to 1 by 2. Clear? Corner frequency, yes. Pole is minus 1 by 2, I know, but corner frequency is 1 by 2. Okay? So when you see corner frequency as 1 by 2, what is the meaning of this? The meaning of this is, so initially the magnitude plot may be anything. Suppose let us say this is a logarithmic graph, right? Assume that as we have the value of k equal to 1 at DC k is equal to 1, static gain or DC gain is 1. So at low frequency your magnitude plot starts from 0 dB, right? So it goes flat till the value of this corner frequency 1 by 2. Clear? So which is actually called as a pole of order 1. Pole of order 1. Clear? Pole of order 1. By the time when the omega value is 1 by 2, then approximate Bode plot or asymptotic Bode plot, approximate or asymptotic Bode plot, it will start decreasing its slope. Clear? Because it encountered the magnitude plot is all the way happily going like this, right? But when it see the corner frequency, its slope changes. But whether the slope decreases or increases, that depends on whether your corner frequency represents pole or 0. Now your corner frequency is a pole, then the slope will decrease. Earlier, what is the slope here? It is a flat line, so 0 dB per decade. And now the slope decreases by 20 dB because you have pole of order 1. When we have pole of order 1, the slope decreases by 20 dB per decade. So that means 0 dB se 20 dB less ho jayega. So how much it will going to get? Slope will going to become now minus 20 dB per decade. Clear? Minus 20 dB per decade. Very easy. And this is approximated Bode plot. So the error between the approximate and exact Bode plot, approximate or asymptotic and exact Bode plot is minus 3 dB at corner frequency. At corner frequency, the error will be more. Clear? Suppose if I have 2 here, what does it mean? It means that we have a pole of order 2 at the same corner frequency, correct? Pole of order 2 at the same corner frequency. If we have pole of order 2, then it will become minus 20 into 2, which is actually equal to minus 40. That's all. Minus 40 dB per decade. So you must identify how many poles are there, how many zeros are there. At poles, the slope will be decreased. At zeros, the slope will be increased. The slope will be increased. I hope I have conveyed the message. Now in the similar case, suppose if I use in the another way, instead of taking this, I will take like this. So let me see how many of you will going to answer here properly, right? So everything is same, but now I am changing the function. So I am changing the function. Maybe you can take like 1 plus 2s. Now when you equate this is equal, s is equal to 0, then obviously you will going to get 0 here and 0 of minus 1 by 2, but still the corner frequency is 1 by 2 only. Basically corner frequency is nothing but the modulus of pole or modulus of 0. Please note down this point. Modulus of pole or modulus of 0. Now tell me what will going to happen. Even in this case 1 plus 2s also the corner frequency is 1 by 2, but it is the 0 of order 1, correct? So 0 of order 1 means the slope should increase, not the magnitude. The slope will change. The slope will increase. How the slope will increase? From here it will go upward direction, and if you see 0 dB se increase ho jayega. Kitna ho jayega? So 0 dB per decade to another 20 dB per decade, because you have a 0 of order 1 here, correct? 0 of order 1. 1 second. 1 second. 0 of order 1. 0 of order 1. So it will going to become like 20 dB per decade here. 20 dB per decade. I hope it's clear to everyone. Yeah, very good Raghuram, very good Roman, very good Roman. Plus 20 dB per decade. That is exactly I told you here. If you have zeros of order n, then it will change the existing slope by 20 dB per decade. So now I have a question to every one of you. Just think like this. Suppose, let us say like this, okay? Right? So let us say like this. Yes. Right? So or else it may be like this also. Initially the slope might be like this, right? Initially the slope is like this. Initially the slope is minus 40 dB per decade here. Minus 40 dB per decade. All of you please let me know very clearly. Right? Your cakewalk for us because of you, sir. Thank you very much, Raghuram. Thank you very much. So it's a lovely feedback and appreciation. Thank you very much. So initially the slope is minus 40 dB per decade. Now it is actually facing 1 by 2, which is a corner frequency, and it is the 0 of order 1. Now tell me what would be the net slope after this now. Now I remove this one. So let me remove this one here. Okay, let me remove this one. And I have corner frequency of 1 by 2 here. Tell me what will going to happen. We all know that this is the 0 of order 1, right? 0 of order 1. So let me say it is 0 of order 1. Minus 40 dB per decade, this is the slope at which it is going slowly downward direction, correct? Slowly it is coming downward direction, right? So when it is seeing a corner frequency which is of 0 of order 1, what will be the slope after this? What will be the slope after this? So now you must be very careful with this. These kind of things are dangerous. 0 of order 1, okay, 0 of order 1 creates a slope change of plus 20 dB per decade to the existing slope. Yeah, adds 20 dB per decade to the existing slope. So before that, what is the existing slope? Earlier it was 0 dB per decade, but now before this 1/2, the slope is actually minus 40 dB per decade. Now what happens is, when 0 of order 1 comes, it will add a positive 20 dB per decade to the existing slope. Existing slope is minus 40 dB per decade. Now for that, a 20 dB per decade will be added. Then what is remaining now? Minus 40 plus 20, all the way you will be able to understand that it will be like 20 dB per decade. So this is now minus 20 dB per decade. Clear? Minus 20 dB per decade. Right? Now most of the times the gate questions will be like this. They won't give this one. You don't know really whether this is 0 or pole. Okay? You don't know whether this is 0 or pole. At that situation, by looking at this, what we need to do? By looking at these two, right? So look at these two and let me know. See, in the single question, we can keep a lot of questions. The only thing is you need to hang on me, right? You need to hang me, and you have to catch me. Then you will enjoy the rhythm of the class. Okay? So here, please let me know what will be the situation now. Minus 40 dB per decade to minus 20 dB per decade. That means from here to here, what is the slope change? Minus 40 dB per decade to minus 20 dB per decade means the slope is increasing by 20 dB per decade. That means the slope change, what is created, slope change is equal to 20 dB per decade. Slope change is 20 dB per decade means it is the representation of 1 0. Clear? Or 0 of order 1. Okay, so 0 of order 1, that is the meaning of question. So instead of 1, 0 of order 1, that is the meaning of this. I hope you understood. In fact, I have explained all the logics clearly. But however, if you have the value of k, so the k always shift the gain by 20 log k. Clear? Suppose if you have g of s into h of s is equal to something like k, then obviously magnitude of this will be what? 20 log k it will going to become, right? So every time whenever you have k, the overall magnitude plot shifts by 20 log k. 20 log k. That I will explain with the question, then you will understand it. Clear? So well, I have completed a Bode plot. Let's see some questions related to Bode plot first before going to the polar plot and Nyquist plot, so that you will also enjoy a lot, right? I am looking only 50 students are there in the live session, right? So everybody must join and enjoy the section together. Manoj, Raghuram, what is the answer for this question? So the Bode plot of g of s, right, is shown in the figure. The value of p minus z, where p is the number of poles and z is the number of zeros. First answer. Any answer? See here. So omega is mentioned on x-axis, and see how clearly it's mentioned, like it started from omega 0.1. So initial slope of minus 20 dB per decade. What does it mean? What does it mean? Initial slope of minus 20 dB per decade, it means that we have a pole at origin. This is pole of order 1 at origin, correct? So pole of order 1 at origin, and then see minus 20 dB to minus 40 dB per decade. What does it mean? Minus 20 became minus 40 means I'm very sure maybe at this point of corner frequency, let us say this is omega c1 and this is omega c2. For time being, let me call this as a omega c3. So can you please tell me omega c1, this corner frequency is a pole or 0? Any one of you? This corner frequency is pole or 0. At this corner frequency, the slope is changing from minus 20 to minus 40. That means the slope is decreasing by 20 dB per decade. So that means it is a pole of order 1. It is a pole of order 1. Simple. Now when it is continuing like this, now see what happened here. It is becoming like 0 dB per decade, right? So because it is a flat line, so 0 dB per decade. That means from here to here, if you see, minus 40 dB per decade, it becomes 0 dB per decade. Minus 40 to 0, that means the slope is increasing. Minus 40 to 0 means slope is increasing. right? Right, so that means it is a 0 of order 2 here, clear? And then it is continued like this, and from 0 dB per decay it became now minus 40 dB per decade. इसका मतलब क्या है? The slope is decreasing, and that too it is decreasing by 40 dB, so pole of order 2 here. Now sum of all these things, now think carefully, all put together in the overall g of s into h of s, how many poles are there, how many zeros are there? Now if you look at the total number of poles here are how many? I'll give some time. Tell me the total number of poles and total number of zeros. Everybody, I need to see the answer from everyone. Krishnaveni and other one, Sonali, Satyasri. Very good. So somebody is saying 4. Okay. Yes. There is a pole at origin. It is not a corner frequency, right? So, but there is a pole of order 1. So this is one pole and one pole and another 2 poles here. Total number of poles are 4. Clear? Total number of poles are 4. And total number of zeros are how much? Just we have only 2 zeros here. So that is going to be 2. Then I can say P minus Z value all the way it will be equal to how much? 4 minus 2, it is equal to 2. The answer to this question is 2. And I rate this question as a very simple question. But trust me, I have seen a lot of questions like this in the GATE examination. And even when you see the PSU questions, these kind of questions are so famous. Okay. So answer for this question is 2. It is a simple question. Now let's move on to the next question. This is a good question. Let me see how many of you will answer properly. Right. Well, let me read the statement of the question here. The Bode plot of g of s is shown below. The gain 20 log g of s modulus of s is 32 dB and minus 8 dB at omega equal to 1 radian per second and 10 radian per second respectively. The phase is negative for all frequencies. Then what is the g of s here? Clear? So such a good question this is, right? So he himself is saying that at omega is equal to 1, 32 dB is there, that is the magnitude here, and omega is equal to 10. He himself is saying that minus 8 dB. Oh, excellent, right? So omega is equal to 10. It's not omega is equal to 10 then, right? So there is a mistake here, right? So I think minus 8 means it might be here, right? So this is omega is equal to 10, right? It is omega is equal to 10. So it is minus 8 dB. Now relax. Try to understand what is the logic behind the question, right? Logic behind question. So first of all, omega is equal to 1. It is not started from omega is equal to 0. It is not started from omega is equal to 0. If it is not started from omega is equal to 0, what is the first thing I requested you to do? Right? G of s into h of s is equal to k. I don't know what is the value of k. So therefore, it is k divided by s will be there because it is a decreasing slope. It's a decreasing slope, right? So it's a decreasing slope. So therefore, I have taken s in the denominator. But will it be s square or s cube or s power 1? What should I say? So 32 dB to minus 8 dB. What is the fall in the magnitude? Any one of you? 32 dB to minus 8 dB. Minus 8 dB. What is the fall in the magnitude? Can I say the fall in the magnitude? Otherwise, you can see what is the slope directly. Use the slope formula. Slope could be written as magnitude 2. That is how much? Minus 8 dB. This is M2. That's why I told you these formulas. M2 and this is M1. M2 is minus 8 and M1 is minus 32. M2 minus M1 dB divided by log of omega 2 divided by omega 1. Omega 2 is 10. Omega 1 is 1. So 10 divided by 1. Kitna hai ye? All put together how much this is? Everyone. So it is actually minus 40 dB per decade. Minus 40 dB per decade means I should write down this as a k by s square. Simple. This is k by s square. But how do we evaluate the value of k? K is considered as a DC gain, correct? Or k is considered as a low frequency gain. If you don't have the DC frequency in the spectrum or in the figure, go with the least possible value of k. You will get most accurate value of k. I repeat, while you are calculating the value of k, you must only consider the lowest possible value of the frequency in the plot. Okay, then your accuracy will be high. So what do you mean by that? So at omega is equal to 1, they themselves told that this is 32 dB. correct? So therefore, let's consider g of s into h of s right now, which is equal to, already we named it as k divided by s square here. Then g of j omega into h of j omega, all the way it will going to become modulus of this, directly I am writing, it will become k divided by omega square. Then in dB it is equal to 20 logarithmic of modulus of g of j omega into h of j omega, correct? Right? So which is equal to 20 logarithmic of k divided by omega square, and this must be equal to 32 dB at omega is equal to 1 radian per second. Clear? Because when I substitute omega is equal to 1, I must get 32 dB here. So what would be the correct answer here? So therefore I can say 20 logarithmic of k divided by 1 square, that is equal to 32. So therefore I could say logarithmic of k, that is equal to 32 divided by 20. Any one of you, can you please help me? What is the value of k here? K is equal to how much? 32 by 20, one second. 32 by 20. How much? 32 divided by 20 here. So all put together 1.6, correct? 1.6. So therefore k is equal to 10 power 1.6, if I am not wrong, 10 to the power of 1.6 here. Right? This is equal to 39.8. 39.8. The value of k is 39.8. Value of k is 39.8. Therefore, what is the final transfer function now? 39.8 divided by s square. This could be considered as a precious answer for that. So option A is the correct answer. How many of you have already given option A? Lot of students, right? Right. Payesh Kumari and Raghuram. Very good. Hemant Krishan. Lot of students have given the answer. Krishnaveni, are you getting the solution? Or any confusion? Is it everything is fine? Right. Now let's go to the next question here. Well, so I will wait for some time and give some time to you. Every one of you, please look at the question and answer to me. Option A, Rohit Pandey, correct. Ashok, correct. Correct, guys. So let's go with the third question. Find the Bode plot of g of s into h of s. What would be this one? So g of s into h of s is equal to 100 into s plus 1 divided by s plus 10 into s plus 100. Okay. So now when I see all these questions, all these statements, what I understood is, anyway, everywhere it is started from 0 here, it started from 0 here, and it started from 0, right? So, so if you see, that DC gain is different. At 0 it was mentioned like 20, at 0 it was mentioned like 0 dB, and at 0 it is mentioned like minus 20 dB. So what would be the, excellent, right? What would be the best way to solve this question? Very simple. Just look at what is the DC gain here. Okay. So that means, first of all, let's catch up the magnitude. It's not so difficult. The magnitude of g of j omega into h of j omega, this will be equal to, let me write down straight away here. This will be like 100 and all the way 1 plus omega square here, 1 plus omega square here, whole divided by, this will become like 10 square, 100 plus omega square here, and again under root of 100 square, that means 10 power 4 plus again omega square. Now substitute omega is equal to 0 and catch the correct answer. C is right answer. C, very good. C, nice. So sometimes, not sometimes, most of the times the questions in the gate, especially from Bode plot, can be solved via options also. Now substitute omega is equal to 0 radian per second. If I substitute omega is equal to 0 radian per second, what you will going to get? The magnitude will come all the way as, that is equal to 100 will be there here, and then under root of 100, that is 10 into 100 again, right? So it is going to be 1 divided by 10. 1 divided by 10. So 20 log of magnitude or 20 log of 10, 1 by 10, sorry. 20 log of 1 by 10. What is the value here? 1 second. 20 log of 1 by 10, that is equal to minus 20 dB here. Clear? So that means when I keep omega is equal to 0, I should get minus 20 dB per decay. I think option B is the correct answer, right? Guys, so look at that. Option B or C? That's okay. So I think you have calculated. See, when we substitute omega is equal to 0, then we have to get minus 20 dB per decay. Where it is possible to get that? That is possible in only option B, right? Yes, yes, yes. Then maybe. So I think you people might have taken like this is A, this is B, this is C, something like that, right? Option B is the correct answer for this question. Option B is the right answer for this question. Nice. Now let's go to next question of Bode plot here. Fatafat. This question. This question I want the answer just in 1 minute of time. Let me see how many of you will do quickly here. Every one of you fast. How many of you will solve this quickly here? Bode plot of a open loop transfer function is shown below. G of s into h of s. Then tell me which of this proper correct answer here. Every one of you. Every one of you. G of s into h of s. Right? So I want the answer so quickly here. So first of all, it is started with omega is equal to 0.01 and it is having a decreasing slope. That means there should be poles at origin, pole of order 1. sorry guys, pole of order 1 at origin. This is the first thing that should come into your mind, right? So where it is possible, this is not correct and this is also not correct. Finished, right? They both are not correct, right? Right. Sir, B ko C, yeah, correct, Payesh. Now, A and D are out of the phase. Now, either B or C would be the correct answer. But problem is, B and C, anyway the poles and zeros of B and option C both are correct. So, in that case, what we could do is, the only possibility to us is what? We need to look at what is the magnitude at the lowest possible frequency. Lowest possible frequency. What is the lowest possible frequency here? Omega is equal to 0.01. Now, let's select either B or C. Anything, right? Because only B or C are correct answer. Only B or C are correct. One of these two options is correct. Then you select either B or C. So we'll take like B. So if you take B, the magnitude will be how much here? Modulus of G of j omega into h of j omega. That would be given as 40 specifically into under root of 1 plus 100 omega square first of all whole divided by 100 omega square whole divided by this is omega only, that omega, and then under root of what should I say 20 omega square. 20 omega square means this might be 400 times omega square plus 1. Clear? 400 times omega square plus 1. Now substitute omega is equal to 0.01. Substitute omega is equal to 0.01. Okay. If I substitute omega is equal to 0.01, what would be this magnitude here? Can you tell me? So 40 will be 40 only into, when I substitute 0.01 whole square, 0.01 square. 0.01 square is going to become 10 power minus 4. So 10 power minus 4 into 100, it will become 0.01. 1 plus 0.01, it will be 1 almost, right? So therefore it can be written as 1 only here divided by omega is 0.01 only, correct? Omega is 0.01 and again this will also become 1 only almost technically. So how much it will going to become all the way? 40 divided by 0.01, right? This again, yeah, correct. 40 divided by 0.01 is how much? That's what I want. 40 divided by 0.01. 4000. This is 4000, right? So this is the magnitude, but in dB what it will become? So 20 log of 4000, can you say what is the value? 20 log of 4000. Guys, fast. 20 log of 4000, how much it will be? I think very big value it will come. Oh, 72 dB this is. This is coming 72 dB. So that means if you look at omega is equal to 0.01, whatever the magnitude we got here, that if you take in terms of dB, you will be having 72 dB. Oh my god, okay, 72 dB, but that is not your case, it is 60 dB here. Then you may argue with me, sir, 62 and 72 are very rare, so I will go with the option B. That is stupid idea. 72 dB and 60 dB, how they both are near? It is already in dB scale. In dB scale, 65 dB and 60 dB will have a lot of difference. 60 dB and 70 dB, how it will be same? So one thing it is sure that option B is wrong answer. Then blindly you can go for option A. Okay, option C, sorry. Option C is the correct answer. आपको अच्छा नहीं लग रहा है इधर, so you are not interested to say option C, then take it, no problem. So go with the option C only. What will be the change here? according to my knowledge, if you take option C, I'm very sure it will be the only change. You will be having 20 here, and I'm very sure this will also be 20. Then it will become 2000 here. When it is 2000 here, 20 log 2000. What is the value here? Fatafat, every one of you. 20 log 2000 के क्या value कितना है इधर? So 20 log 2000, right? So it will be 66. This is okay, fine, reasonably fine, right? So around 66 is coming. This is better than previous one. If I'm not wrong with the calculation, I can go with the option C. That is the correct answer. Good question. This is good question because it tested your basics very clearly. Not a great question, but it's a good question, decent question, right? Now these things are completed. Now let us look at the polar plot and Nyquist plot. I may take around 20 minutes here, polar plot and Nyquist plot. I require strong attention from your side. Okay, very strong attention. After this polar plot and Nyquist plot lecture, trust me, you will never forget anything. Okay, but only thing you need to assure me is be with me. Okay, be with me, right? So first thing is polar plot. Polar plot, I can say, suppose g of s into h of s. It's a frequency response plot undoubtedly. Let us take g of s into h of s as 1 divided by, for time being, let me take s into s plus 1. Clear? S into s plus 1. Whenever I give this kind of function, lot of students, they study different formulas like type 1 को ऐसा कर दो, type 2 को ऐसा कर दो, type 3 को ऐसा कर दो, type 1 minus type 2 को ऐसा कर दो, right? Order 1 को ऐसा कर दो, like 20 to 30 formulas, or else at least 5 to 6 conclusions they remember. I truly agree that if you remember this many conclusions, after a lot of revision work, you will be able to do accurately in the examination. In the exam, when you are already in deep pressure, so you will do mistake when you remember multiple things. Best is always basics, right? So sir, you have to take 10. 10 is there here. 10 is there in the option, guys. Our person is saying something. Let me see. 10 is there in the options. I think it's not there. Just wait me 1 minute. Oh, got it. Thank you very much, guys. Right? Guys, have you seen here? Actually, I need to take 10 here, right? Super, wonderful, right? So let me take 10 and see what will be the situation here. Okay? Because, thank you very much, guys. So it is 10, right? 10 it is. So then I need to multiply with the 10 here. Then it will be multiplied by 10 and then it is going to be 1000 here. Oh, excellent. 1000. Then 1000. Then it is going to be 60 dB. Then we will be getting accurate answer. Perfect. Lovely. What's your name? Electronics and Communication Engineer. What's your name? 1000. Perfect answer. That is excellent. Nice. Thank you very much for correcting me. Now let's come back to our original discussion, polar plot. In polar plot, I'll give you a simple logic. Just follow that everywhere, irrespective of the every situation, you will get correct answer. And you will also get correct answer for Nyquist plot also. That is bonus. So, but you should follow strictly this one. G of s into h of s is this, right? First of all, replace s is equal to j omega. This is the natural step. G of j omega into h of j omega. Shall I give shortcut or not? I will give a shortcut, and though it looks like a conventional and traditional approach, the conventional and traditional approach, which is very basic here, is the shortcut. Okay, that is only shortcut. So please see, g of s into h of s would be written as 1 divided by 0 plus j omega. First of all, right? I am doing the entire steps, so please hold on for some time. 1 plus j omega. Then what is magnitude here? Magnitude would be written as the modulus of g of j omega into h of j omega, particularly h of j omega. What is this value? 1 divided by omega only. This is, and it will become 1 plus omega square here. What about the phase? Phase would be written as modulus of g of j omega into h of j omega and the denominator, it can be written as, one second, it's phase, because both are there in the denominator. So the first one is phase of 0 plus j omega here, and minus plus 1 plus j omega, because minus is already included at the top. So minus of tan inverse of omega by 0 and minus of tan inverse of omega by 1. So all put together it will become like minus 90 degrees minus tan inverse of omega here, correct? Minus tan inverse of omega. So get the magnitude and phase. That is not so difficult in the examination. But when you practice this calculation of magnitude and phase, like see, one student have already given. So see, that is a thing. Karthik Devaranti, okay, has given the answer as type 1 order 2, something like that. Yes, you can do like that. I'm not denying that. But in GATE, you will get a questions which are very tricky. That time you have to go with the basics only, because I have an experience of around 12 years. I guided more than 50,000 students. I saw a lot of times the students will struggle when a difficult and different transfer function is given. So please see here, omega I am taking here, and magnitude and phase, okay, both I am writing at a time, okay, right. So please see here, otherwise let me see in this way. Yes, 1 second, let me write down magnitude here and phase, right? Magnitude and phase. First, only the lowest possible frequency you keep it, because omega is equal to 0, that would be the least possible frequency we can keep. Highest possible frequency we can keep is infinity, correct? If you want, you can take 1 and 10, it's up to you. You can take one frequency near to 0, one frequency is very high. So 4 frequencies you can take. Calculating at omega is equal to 0 and infinity is very simple. Only at 1 and 10 it's between a little bit difficult, correct? Right. So now at omega is equal to 0, what is the magnitude here? 1 by 0 into under root of 1 plus omega square. So magnitude will be infinity here, because 0 is there in the denominator. When 0 is there in the denominator, it will become infinity. What about the phase? Minus 90 degrees minus tan inverse of 0. So therefore it will become minus 90 degrees here. Clear? So that means the plot initially at omega is equal to 0 will have infinite frequency and minus 90 degrees. And when you substitute omega is equal to 1, then what is the magnitude here? 1 divided by 1 into under root of 1 plus 1. So it is 1 by root 2, which is equal to 0.7. And then magnitude phase is how much? Minus 90 minus tan inverse of 1. That is nothing but minus 135 degrees here. So let me write down minus 135 degrees. Clear? So if it is non-minimum phase system type in all type. Yeah. Surajit Rabaldas. Correct. Perfectly you tell you. That is lovely once. Super. After a lot of time I am seeing you, Surajit. If it is, because there are some questions, if it is like non-minimum phase system, whatever you have studied, okay, like type 1 minus type 2, type 3 minus type 2, this shortcut, that shortcut, this shortcut, finally everything will collapse. That's why I always say that basics are so powerful. Let's hang on to basics, okay? So 0.7 and minus 135. And now keep 10 value. If you keep 10, that's fine. Even if you don't keep 10 also, no problem, right? So let me not use the 10 here. So let me go with the infinite here. Only 3 frequencies, it will not really take, a lot of time. Why do you know? It is class. I am explaining to all of you. So I need to explain very clearly. That's why I have written this magnitude, phase, and then doing this, all these things step by step. But in exam, you don't do all these things, right? Straight away, you will write the magnitude phase plot. So easy. So infinity, when you keep, this magnitude will be 0. And what about the phase? Phase is how much? Guys, when you substitute omega is equal to infinity, minus 90 minus 90, it will become minus 180 degrees here. Minus 180 degrees. Now, when you are drawing the polar plot, kindly follow these suggestions very clearly, okay? So first draw this one, right? Polar plot. I am using, this is 0 degree. We all know this is minus 90 degree, and this could be minus 180 degree, and this is minus 270 degree line. Reverse is also there, that is 90 degrees here possible, and this could be 180 degree. People do say that, and this is 90 degrees like this, and fine, this is 90. So 90 and 180 and 270 this side, pos to 270, pos to 270. So this is what you will going to have. But anyway, right now our phases are in negative trend. So as they are in negative trend, I don't really worry about this, but generally they will have their own significance also. Clear? So they are in negative trend. So just wait for my command, minus 270 degrees. Tell me where the plot is now. So first one, look at that. First one, always try to understand like this. You will not substitute omega is equal to 0. You will substitute like omega 0.001 like that. Clear? 0.001, lowest frequency. That means omega tends to 0. Omega tends to 0 means it is slightly greater than 0.1. Okay, slightly greater than 0.1. So 0 plus I can say. The moment when I say 0 plus here, have you seen the phase trend here? It is going from minus 90 to minus 135, minus 180. What does it mean? It will not become minus 90 now. It will become like minus 90.01, minus 90.02, something like that. So that means instead of writing like minus 90, what I can say is, as I have taken 0 plus here, slightly more than 0, as looking at the trend of the phase, it's coming down, so it will be minus 90.02 degree. Clear? Minus 90.02 degree or minus 90.01 degree, right? Why I'm taking minus 90 to this side? Why I'm taking like minus 90.02? Why I'm not taking like minus 89.2? If it is increasing function, let's see like this. If it started like minus 90 and then it is becoming like minus 45, next if it is becoming 0, then I can say that this is going in the increasing order. Then for more value of omega, instead of minus 90.02, I may take minus 89, minus 88 like that. Okay, reverse way I might take. Okay, but now looking at that, apply that concept here. So when omega is equal to 0, you should have the phase of minus 90.02 may be very big like that, but it must also have infinite radius also, infinite radius. This length is actually nothing but the magnitude. This length indicates the magnitude here. Clear? One second. The length indicates the magnitude here. Just give me 1 second. Clear? Length indicates the magnitude here. So, and then this is the first vector. Second vector का length कितना है? बहुत छोटा है इधर. So 0.7 and minus 135. Minus 135 and 0.5. 0.7 means minus 135 may be like this here, and 0.7 is a very short vector, right? Very short vector here. Just give me 1 second. So it is the first thing, so it is looking little bit time taking, but generally this is the best way to solve these questions, right? Right. So this is second vector. What is the third vector? Third vector has a magnitude of 0, phase is minus 180 degrees. So third vector, magnitude 0 means at this point only, minus 180 degrees means this axis only, correct? So first point, second point and third vector. Clear? Third vector. Now join the tips of all these three vectors. Join the tips of all these three vectors. That means start from here, because this first point represents omega is equal to 0. Last point represents omega is equal to infinity. To be very technically speaking, this is 0 plus and this is infinite minus. That means almost more than 0, less than infinite, less than infinite. Then how I can connect all these three tips here? The only possibility is the tips are like this. Clear? So this is the only way you can connect here, right? Now the great point here is omega 0 to infinity it is going. So therefore I could say all the way this is considered as your polar plot. Clear? Polar plot. That's it. Now I have a question to every one of you. Look at that. At point number 3, what is the magnitude and phase? At point number 3, what is the magnitude and phase? Don't look at the table. Look at the plot and tell me at point number 3, what is the magnitude and phase? Guys, fast. At point number 3, what is the magnitude and phase? Everyone must answer here. What is magnitude and phase at point number 3? Why no one is answering? Oh, I think there is some delay. Fine. Okay. At point number 3, what is the magnitude and phase? Yes. Guys? Yes. Yes, yes. Magnitude is 0 and phase is touching minus 180 degrees axis. Likewise, this simple graph can teach you what is the magnitude and phase so easily. Clear? Now the most important thing is this is a polar plot. I hope you really understood and enjoyed this also, right? Just to give me 1 second time. Just to give me 1 second time. Let me draw, let me sketch it very clearly. Now remove this one. Right. Just give me 1 second. Right. So this is exactly what we got it, right? So, and arrow direction also we know. This is this way it is going on. This is the polar plot. Nobody can deny the fact, right? Now I'll ask one by one question to every one of you. So just look at this. Assume that there is another polar plot like this. Assume that there is another polar plot like this, and this is 0 degree, and maybe this might be 90 degrees here, and this is 180 degrees here, and this might be 270 degrees here, and then 0 degree. Likewise, it is coming in this clockwise direction. Clear? So I have drawn a polar plot like this. Clear? So like this. Right? Like this it is coming. So please see the tip, how it is going. Okay, so this is very, very important. The understanding the tip and the direction, phase calculation, everything is important. So please see here. It's coming like this, going like this. It's coming like this. Now, every one of you think logically and tell me. Omega is equal to 0 and omega is equal to infinity. What is the phase at omega is equal to infinity? Please tell me, every one of you, what is the phase at omega is equal to infinity? What is the phase at omega is equal to infinity? Whether minus 180 degree or 180 degrees or 270 degrees. At omega is equal to infinity, phase is 180 degrees or 270 degrees. Or phase is 180 degrees or 0 degree, phase is 180 degrees or 270 degrees, what exactly it is? I want the answer from you. Very good to see. Nobody is actually going out. Right, Surjit, very good. That's the catch. Nandi has shown that, Nandi has mentioned it as 180 degrees. I know some of the students, they will do the mistake. That's why I am explaining this. So look at, follow the plot, right? So start from 0. Omega is equal to 0. It's almost at 90 degrees. And slowly the magnitude and phase are changing. And then it's going like this. And it is following the line of 270 degrees and coming and finally settling at 270 degrees, right? So at omega is equal to infinity, the phase is actually phase of j omega into h of j omega is equal to, here it is the 270 degrees, or we can also say minus 90 degrees. A lot of students, they take like minus 180 degrees. That is wrong answer. Clear? 270 is the correct answer. Now I have a question. Suppose, let us say, I have maintained from here to here, here to here. I told you that this is point number 2, and I told you that here the magnitude is 4. Clear? Point number 2. This is second point. Now, can anybody say what is the magnitude and phase at point number 2? Fatafat. Magnitude and phase at point 2. Magnitude and phase at point, 2. Point 2. Magnitude and phase. Guys, Sachasri and everyone, please answer here. Rohan, Roman, Raghuram. What is the magnitude and phase at point 2? Point 2 का जगह पे क्या है? Magnitude and phase both. Very good. Abhishek Agnihotri. Good. So at point 2, I can say, point 2, I could say, right, magnitude became modulus of j omega into h of j omega. I could say that that is equal to 4. Okay, magnitude is 4. So why not final angle will terminate at random values like minus 48, 120 and so on. Why it's only at 0? Just give me 5 minutes, I will explain. This is a wonderful question actually. Just let me complete what I would like to say here. It's a good question. Because okay, first let me complete. The phase of this at point 2 is 180 degrees, right? Phase is going to be 180 degrees. Either we can write down 180 degree or minus 180 degree, not a problem here, correct? Right? But now Rohit Pandey, Roman, Surajit, whenever Surajit is there in the chat box, he'll ask always a good question. Okay, Abhishek Agnihotri and Ravi Shankar, Raja, Manu, Sachasri, every one of you think and tell me, at point number 2, you have said clearly about the magnitude of the loop gain 4. Phase of the loop gain is minus 180 degrees. But what is the frequency at point number 2? Can you tell me or not? Tell me what is the value of frequency. Don't be over smart and say that this is omega PC. Don't say that. I'm asking what is the value of frequency. What is the value of frequency? Numerical value of frequency. न्यूमेरिकल वैल्यू ऑफ फ्रीक्वेंसी कितना है? न्यूमेरिकल वैल्यू ऑफ फ्रीक्वेंसी क्या हो सकता है इधर? पॉसिबल टू मेंशन दैट? विल यू गेट और नॉट? You can say that omega is somewhere between 0 to infinity. Can you say what is the exact value of omega? You cannot say the exact value of omega. You can say magnitude and phase. That is the beauty of polar plot and Nyquist plot. From the polar plot and Nyquist plot, we can actually calculate the magnitude and phase, but without knowing the value of frequency. Okay, that's one of the crazy advantages, isn't it? In Bode plot, you need to know the frequency to evaluate the magnitude and phase. But here, without knowing what is the frequency, you are able to say what is the magnitude and phase to me, correct? Right? Yes. Are you understanding what I am saying? Excellent. So that's advantage or disadvantage. It's a great advantage, right? I don't really require to know what is the frequency, damn. But I can say what is the magnitude and phase, how the magnitude and phase relatively changes when the frequency changes from 0 to infinity. Clear? But in Bode plot, magnitude versus frequency is there, phase versus frequency is there. But in polar plot, you will be having only magnitude and phase representation in a single plot, but frequency will not be there. Okay, right? That's the crazy thing, right? So anyway, I will show you what is the advantage of this thing and all in few minutes of time. Give me some time. But before that, Surajit has asked one question to me. Okay, Surajit Das has asked one question. Why only minus 90, minus 180? Why not like minus 120, minus 20 like that? See, Surajit, whether you develop the transfer function in classical control theory or state space model in modern control theory, whether in a transfer function of the classical control theory or state space in modern control theory, for any plant or for any system, okay, we will be having poles and zeros, right? So G of S into H of S, any system you take, right? Either you will be having K by S into S plus A into S plus B, something like this, poles and zeros, correct or not? So the idea is the pole at omega is equal to infinity, the pole at origin can contribute minus 90 degrees. Even the real pole also create a value of minus 90 degrees only. That means the phase of this at omega is equal to, at omega tends to infinity, it creates minus 90 degrees only, and it creates plus 90 degrees here, and it creates again 90 degrees so positive. So what you understood here, all the way your final angle will be every time the multiple of 90 degree. Only your final angle will come. Suppose let us say I don't have this one. Assume that I have maybe like this, right? I have my like this. Then what is the net phase at omega is equal to infinity? Minus 90 and plus 90 will get cancelled, and net phase will going to become 180 degrees because you have two poles here, correct? So 180 degrees is actually nothing but 2 into 90 degree, right? Likewise, the moment when the omega tends to infinity, the phase gets the some multiple, some numerical multiple of 90 degrees, numerical multiple of 90 degrees. This is the reason behind this is at omega is equal to infinity, the maximum phase is a phase offered by pole is minus 90 degrees, maximum phase offered by 0 is plus 90 degree. That's the reason why you will going to get like this. Surajit, I think I have answered to you. So please let me know in the comment section. Have you got the point here? That's why when omega is equal to infinity, we will be ending at either 0 degree, 90 degree, 180 degree or minus 270 degree, like that, multiples of 90 degrees. Surjit, please let me know. Is it clear? Surjit Rabidhas. Right. So I have done with the polar plot. So this is the basic idea of polar plot. Now I am going to explain the way how the Nyquist plot can be drawn here. Here itself I will explain. So Nyquist plot, unlike polar plot, so just let me go ahead one step here. So Nyquist plot is considered as a complete frequency response plot. Please keep this point in mind first of all. Complete frequency response plot. First of all, complete frequency response plot का मतलब क्या है? So the frequency range, so far we are looking at only omega is equal to 0 to infinity, right? So that means so far we have seen omega 0 to infinity, correct? In fact, we are looking at 0 plus to infinity, correct? 0 plus to infinity minus, that means more than 0, less than infinity, more than 0, less than infinity. But if you see, omega is a number, right? So we all know minus infinity to infinity, a value can take any value between minus infinity to infinity, right? If it is a variable, omega is a variable, that variable mathematically it can take any value between minus infinity to infinity. Physically chhod do, physically whether it's possible or not, that will come later when we really implement the system. But before implementing the system, we will do everything mathematically only, right? So frequency go from minus infinity to infinity, correct? So the most beautiful point here is the scale of minus infinity to infinity can be split like this, right? Omega is equal to 0 also we can make it here. Now the omega is equal to 0, what I will do is, let me take just one value left side, one value right side here. What I call this as, instead of making 0 here, I will segmental, divide this segmentally like this. That means I'll try to keep this as 0 minus, that means just before 0, and 0 plus just after 0. But this is actually 0. Omega is equal to 0. Clear? If you apply the limit, there is no fundamental difference between 0 plus and 0 minus. It looks like same. Clear? So far what we have drawn is between 0 plus to here, infinity. And that is what we are naming as polar plot. Clear? That is what we are naming as polar plot. And whatever we are going to draw from here to here, that is considered as inverse polar plot, or it is also called as a mirror image of polar plot. Clear? This is inverse polar plot or mirror image of polar plot, right? So the polar plot and mirror image of polar plot both integrated together will give 90% of the Nyquist plot. 90% of the Nyquist plot. There is a small story that has to be done between these 2 points, but I will give a shortcut. But those who want to get the real concept about what is happening from here to here, please go to my Nyquist lectures in recorded lectures. If you want in-depth knowledge about this one, recorded lectures, I have explained, more beautiful way, like I have taken, r into e power j theta, and I have varied the theta with respect to radius, and I have sketched the complete Nyquist plot in the entire S-plane. Lot of examples I have taken, that is pure mathematical analysis, detailed manner I have explained. But as far as the exam is considered, I know you are not so interested to go for the entire detailed procedure, you are only loving the shortcuts, okay? So let me go with the shortcuts. So take a polar plot and then take the mirror image of the polar plot, that I am naming here as a inverse polar plot. But instead of that, in the plots way, you can even take like this. Let me call this as a polar plot here. 1 second. This is the polar plot, and this is MPP, that means mirror image of the polar plot, and both they have to be integrated properly at this point, then we will going to get Nyquist plot. So yes, I will tell you. So I hope you understood so far. Is it interesting? First of all, please let me know in the comment section. This is the way how you should see the Nyquist plot, because the Nyquist plot technically covers the whole range of frequency from minus infinity to infinity. This is mathematical analysis, right? Because you need to know whether the closed loop system is stable in for all frequencies or not, correct? So now moving ahead, how do we sketch that one? So what really we need to do at this 0 minus to 0 plus, when the omega jumps from 0 plus to 0 minus, because of the difference between poles and zeros, the plot will make an infinite radius. Actually, I'll show it to you how exactly it will really make it clear. So just see here. First, this is polar plot or inverse polar mirror image of polar plot. Guys, fast. I want the answer from every one of you. If you sit just like that, I don't really appreciate you. Okay, g of s into h of s, आप लोगों को पता है ना? So I already told you this point. That is s into 1 plus s, right? So 1 plus s. This is polar plot or mirror image of polar plot. This is simply polar plot. Why I am saying this is simply polar plot? This is polar plot because here you started from 0 and you went to infinity, right? So plus infinity, right? Okay, infinity. Now take the mirror image of this polar plot. How do we take the mirror image of this polar plot? Okay, so just take the mirror image of this polar plot. I can't teach that also, right? So mirror image, you are all engineering graduates, you need to know how to take the mirror image of this. So the mirror image of this would be like this. Once again, right, like this. This is the mirror image. When you take the mirror image, okay, when you take the mirror image, then be relaxed and look at very carefully, very carefully. End of the mirror image, okay. So end of the mirror image would be this one. Clear? This is the end of the mirror image is the first point, and starting of the original graph. End of the mirror image and the starting of the original graph. I repeat, end of the mirror plot. So this is a mirror plot here, mirror image of the polar plot. End of this mirror image should be connected to the starting of original graph, right? So that means end of the mirror image should be connected to the starting of original graph in clockwise direction with infinite radius. Clockwise direction with infinite radius means this way. This is the only possible way. Check if you want, you can check, right? So clockwise direction with the infinite radius, right? Then we call this as Nyquist plot. Clear? Then we call this as a Nyquist plot. Now, what is more important is this is considered as the end of mirror image plot, mirror polar plot, mirror image, and this point is considered as a start of or starting point of original polar plot, that is PP. Clear? Now relax. You know this direction is like this, and you also know this is going to be the plot direction here. But I request you tell me what would be the direction here. What would be the direction? The direction would be like this. Clear? The direction would be like this here. Clear? The direction would be like this. And the craziest part here is, most craziest part here is, this is omega is equal to 0 minus, and this one here. So just let me show one important thing here. So please be with me. Don't go out here and there. This part here, when it is ending, that is omega is equal to infinity, and when it is starting there, this would be like omega is equal to minus infinity. That means the mirror image started from omega is equal to minus infinity. Understand guys, understand properly. Mirror image started from minus infinity, omega is equal to minus infinity, all the way it traveled to where? 0 minus. That is what exactly I told you earlier. Where is that? Right? So mirror plot starts from omega is equal to minus infinity and all the values changed till the 0 minus. So now you understood that this is the way how the plot goes from minus infinity to 0 minus. Correct? And interestingly from 0 plus to infinity also, आप लोग को पता है 0 plus to infinity already आपको पता है ऐसा हो सकता है, right? So it will happen like this. 0 plus to infinity, it will come like this. So that means technically speaking, from minus infinity to 0 minus, this is what it will going to happen, correct? And then 0 plus to infinity, this is what will going to happen. Then the question is, what happens between 0 minus to 0 plus? Correct? This is what will going to happen from 0 minus to 0 plus. Clear? 0 minus to 0 plus, when you are connecting, you should connect with the infinite radius in clockwise direction. Clear? Right? It can also move in anti-clockwise. No sir, in transfer function is unknown. No. Not like that. Okay. Surajit, it's not exactly like that. Hemant Krishna, it is also not like that. Right? So if you really want to know why only clockwise I am taking, then I think you need to go with the recorded lectures only, because it's a big concept, lot of concept. I have explained that in detailed manner, right? Those students who has that doubt, I suggest just to go for one lecture, because in Nyquist plot I took almost around 5 lectures in recorded, 5 lectures in BEP app, right? So just go to that construction of Nyquist plot, there you will be able to understand. Clear? So now let me go ahead because people are asking me to continue. So I think you understood the way how the polar plot and Nyquist plot are both are associated here, correct? So yes, now let me move on to the next one. Yeah, I have Bode plot questions आप लोग कर दिए ना, so it's completed. Now yes, this done. Yes, let's see this one. See guys, how it was actually mentioned. Okay, how it was actually done. So this is the what you say, like a plot taken from the previous gate question, right? Yeah. Surjit, you are right. Absolutely, you are right. Outstanding. Good. Right. So you see how the way how he has given minus infinity. This is minus infinity. Minus infinity. This is the way how it is going on. Right. And up to 0 minus. And from 0 plus. 0 plus. It is the way it is going on. 0 plus. So first of all, always try to see from 0 plus to plus infinity. Infinity. Basically, this is plus infinity. How exactly 0 plus 2 infinity means? This is your actual plot, polar plot, correct? And this is a mirror image of the polar plot. This is the mirror image of the polar plot. So now technically, how does it looks like? So I'll tell you simply. So just look at that. This is really a wonderful question. See this. Now if you see only 0 plus to infinity, plus infinity, the polar plot is like this for this. This is the polar plot. Clear? This is the polar plot. Now chhod do, sab kuch chhod do. Don't go with anything. Just look at this. And I was saying that this is the starting. Omega is equal to 0 plus, and this is omega is equal to infinity here. Correct? Right. Now for this polar plot, tell me how would be the Nyquist plot looks like. This is anyway 0 degree, we know all, right? And maybe this is going to be 90 degrees here, and this is all the way 180 degrees here. I don't deny the fact. And this would be 270 degrees. So maybe at omega is equal to 0, it has 180 degrees phase, right? 180 degrees phase. Is correct? Hai? Yes. 180 degrees phase. There is a wrong thing in this question, but anyway. But what is the Nyquist plot for this one? Any one of you? Can you tell me? So this is the polar plot. This is the polar plot. How do you know polar plot? Because omega ranges from 0 to infinity. But omega 0 to infinity, this is fine. Absolutely okay. I too agree with that. But omega is equal to infinity. I mean like second phase. Mirror image, how to take this one? Mirror image you can take for this like this only. There is no other option. You need to do like this only. This is considered as a mirror image for this, right? So mirror image of polar plot is like this. The direction is also known to us. Direction is also very clear. This is the direction of this. आप लोग ऐसे check कर दो. 0 to infinity is here like this, right? And then this is already I told you minus infinity, and this is omega is equal to 0 minus. Clear? Omega is equal to 0 minus. Then the beautiful thing is minus infinity to 0 means this is the direction here. Correct? This is the direction. Well, we got up to here. No doubt about that. Now the problem is, I asked you to do what? End of the mirror image. This is the end of the mirror image. That is the first point. And end of the mirror image. So let me take here. End of mirror image. This is considered as end of mirror image of the polar plot. And this point is considered as a starting point of original plot or polar plot. These 2 points should be connected. Then some brilliant students, what they do, you know, they will simply take like this and connect. They argue with me, connect ho gaya sir, ye connect ho, you know, dono connect ho gaya, then what is the use of this one, right? So I told you that these 2 has to be connected in clockwise direction with infinite radius, right? With infinite radius also मैं बोल दिया, right? So I told you that, right? I told you now, see from the given plot, 0 plus to infinity, 0 plus to infinity, that segment is considered as polar plot. I already told you this point. Have you seen? Our basic idea is this only. Frequency changes from 0 plus to infinity, that is called polar plot. So in the plot, it was clearly mentioned that 0 plus to, one second, where is the plot? Yeah, 0 plus to pos infinity. That's why the upper one I have taken as a polar plot. Correct? So Ravi Shankar, is it clear to you? Right? So now some brilliant people kya kar sakta hai, no? So they will take like this and they will connect and they will say, no, so it's connected. So I will be keeping this only. This is only Nyquist plot. You do what you want to do. No, it's not like that, right? I told you 100% concept, but you will take only 50% of concept and you will execute only 20% of the concept and you will get 0 marks for that, right? So this is not the way. I told you 2 things. The end of the mirror image should be connected to the starting of original plot in clockwise direction with the infinite radius. That means with the infinite radius means you need to connect all the way like this. Clear? Then it is considered as your Nyquist plot. Now you check, you will be getting the same thing here. Clear? So that is what exactly it is, right? So now technically if you see, the arrows must be connected. So please see here. Nice. This is the way how it must be connected. Now see whether the closed loop is formed or not properly. Closed loop should be formed at the end. Then only it is correct. Then only it is correct. I hope I have conveyed the message to you. It's very happy to see the number of students here. Right. So then the primary question will come to you. What is the use of this? Obviously like what is the advantage of this frequency response plot? Right. Ultimate advantage of the frequency response plot is to understand the stability of the system and to design the system such that our expected requirements will be reached out of it. Clear? So that is a major requirement. For that, you require to know two different concepts, gain margin and phase margin, because these two are very important as far as the stability points are considered. Suppose let us say, how do we find the gain margin? Okay. So to find the gain margin, first of all, we need to find the phase crossover frequency. What do you mean by phase crossover frequency? The frequency at which the phase of the system, phase of G of j omega pc into h of j omega pc, that is equal to minus 180 degrees. The phase should be minus 180 degrees, and at that frequency, calculate the magnitude, and then gain margin is actually nothing but 1 divided by that. So usually we call this gain margin as kg. Clear? Kg. If you want in dB what will going to happen? In dB, one second. If I say gain margin in dB, how do we calculate that one? In dB means gain margin could be written as 20 log of 1 divided by modulus of G of j omega pc and h of j omega pc. Clear? That's it. So this is actually called gain margin. Roman that you need to do, for going with which transfer function is giving at omega is equal to 0, minus 180 degrees, and how the phase at omega is equal to infinity, which transfer function is giving 0, evaluate that, then you will get to know what is the answer with that. Okay. Otherwise just wait for me, because I already came to this concept. I'll go back after some time. Okay. This is about gain margin, right? And when it comes to phase margin, to calculate the phase margin, first of all you have to fix the gain at 1. So that means magnitude of this modulus of G of j omega gc, h of j omega gc, that is equal to 1. So if you equate this to 1, then you will get the gain crossover frequency. Clear? Gain crossover frequency. Does the plot intersect with minus 180 degrees? Previous question. Yes, it will intersect. It will have to intersect. Okay. So calculate the crossover frequency omega gc, fine, and then right, calculate the phase at that omega gc. So that means once you calculate omega gc, then calculate the phase at that frequency, and after getting the phase, then the phase margin would be written as phase margin is equal to 180 degrees plus the phase what you calculated at omega gc. Clear? Gain margin and phase margin are such a beautiful concepts. Believe me guys, if you really want to enjoy, I have taken one YouTube session, right? I don't know how many of you attended that YouTube session, but if you want to taste the exact flavor, I have explained like India border and Pakistan border, and from there we have related the concepts to the control system, right? So the students really who attended that YouTube session, they have enjoyed a lot. So in case if you want to get a real depth about this gain margin and phase margin, do visit YouTube session or the recorded lecture. You will really get a plenty of idea about that. Yes, Ravi Shankar, correct. Now, after getting this, what is the main theme of that? Why do we really do all this nonsense? As I said, our ultimate purpose is to find out whether the system is stable or not. The very first thing what you must know is, okay, please look at these 2 points, very, very important these are. Suppose if the gain margin and phase margin both are positive. Okay, gain margin is positive, phase margin is positive. What does it mean? We have left out some margins. We are having some margins which are available in gain as well as phase. So naturally we are having some margin After that margin only system will become unstable. Closed loop system will become unstable. After that margin, the closed loop system will become unstable means currently the closed loop system is stable. Correct? Currently the closed loop system is stable, isn't it? Right? So therefore, phase margin, gain margin both are positive means the closed loop system is stable. I repeat, closed loop system. The stability is for closed loop system. Please maintain that rapport. Closed loop system is stable, but the condition for that is omega PC must be greater than omega GC. Okay. Suppose if omega PC and omega GC both are equal, then that is where the marginally stable system will come into the picture. Phase margin, gain margin both are 0. Phase margin, gain margin both are 0. इसका मतलब क्या है? It means that already you are at border. Please don't add anything. Okay, because your margins are left out. There is no margin in gain, there is no margin in phase. If you add something, then the system will become unstable. That is the meaning of that. Clear? So in case if omega PC is less than omega GC, then absolutely phase margin is negative, gain margin is negative, and the system, closed loop system, will become unstable. Clear? Now I have a question to every one of you. Just assume a situation that I have some system. Okay, all of you please see. I have some closed loop control system, and its omega PC of that is infinity radian per second. Okay, I don't know, I don't show what is the system, but I am saying randomly that omega PC is equal to infinity. Okay, omega PC is infinity. Now omega PC is infinity. No, wrong. Raghuram, wrong. Omega PC greater than omega GC, the system is stable. Omega PC greater than omega GC means the system is stable. Please look into that. So I have some system, closed loop system, and for the closed loop system, omega PC is equal to infinity. Okay, omega PC is equal to infinity. When I say omega PC is equal to infinity, when I say omega PC is equal to infinity, whether the closed loop system is stable or unstable. Please let me know, stable or unstable. Because when omega PC is infinite, that means it's a very high value, then omega GC, either it can be infinity or it has to be less than infinity. Correct? It has to be less than infinity. When I keep omega PC, just look at here. Omega PC is here, infinite means. Omega GC might be here or here or here, but it may be maximum of this, right? Or it will be below than this. Why? Because this itself, it is a high value. Omega PC is infinity. Then omega GC, either it will be here or it will be here. So then I can say, in the worst case, the system may be marginally stable. In the best case, the system is stable. There is no point for omega GC can cross omega PC. The reason is omega PC is already infinity. Clear? The reason is omega PC is already infinity. So when omega PC is infinity, it really means that our system, for our system, there is no possibility that the closed loop system will never become unstable. This is the reason why for a given closed loop system, we always use compensators and controllers such that the overall omega PC will become infinite. Because once omega PC is infinite, I need not to check about omega GC, because pata hai, so omega PC is infinite means omega GC cannot cross omega PC. So the system will be either marginally stable in the worst case, in the best case it will be stable. Clear? All of you please let me know, have you understood this concept clearly? Every one of you. Every one of you. Perfectly stable, excellent, excellent, very nice, excellent. Omega PC is infinite means I fixed the value of omega PC at very high, far away from the omega GC. Then obviously I will be at stable situation most of the time, correct? So in the other case, we always try to keep omega GC also at 0 radian per second. Omega GC 0 radian per second. That means if you keep omega GC at 0, that means you are keeping the omega GC such a low value. When you keep omega GC at such a low value, you cannot bring this omega PC lower than omega GC, correct? Because omega GC 0 itself, it is the lowest value. How can you bring omega PC lower than this one? It's not possible. Either omega PC should be high or else it should be equal to 0. Even in that situation also, the system will not become unstable. So that means either by using the compensator or controller or doing any kind of adjustments, we will always ensure, like being a control engineer, we always ensure that the overall closed loop control system should have either the omega PC very damn high like infinity, or omega GC should be damn low like 0, then I am very sure that the closed loop system will never become unstable. Closed loop system never become unstable. I hope I have conveyed the message. Now, if you do some kind of improper adjustments, then what will happen is omega PC will come down slowly, omega GC will increase. See, omega PC, omega GC gap ज़्यादा होना पड़ेगा, right? You should have more gap between omega GC and omega PC, then the margins will be high, right? The moment when omega PC is decreasing, omega GC is increasing, you will be under trouble. The moment when both of these two are equal, finished, your margins are 0. And suppose if omega GC crosses omega PC, then you will going to have the negative value for gain margin and negative value for phase margin. That means you are in unstable region. And if it goes still high, then you will be deeply unstable. Okay, if you still go high, then it is absolutely unstable and very, very unstable. Clear? So this is a beautiful concept. I hope I have clearly explained, very well. So in case if anybody really have any doubts, please ask me here. I'm ready to discuss that. But how do we do this calculation from Bode plot? Okay, because this gain margin, phase margin, we must know from the Bode plot also, right? So especially like from Bode plot, suppose if you see there are two plots here, magnitude plot and phase plot. I ask only one question. In this case, you see omega GC is nothing but the frequency at which the magnitude is 0 dB, or we can say omega PC that is equal to 1 or in dB means I should say magnitude of this omega PC, h of omega PC, it must be 0 dB, isn't it? At omega PC it is 0 dB, dB means it is 0 dB, normal magnitude means 1. Now you see here clearly, I will give some numbers, then you will understand. Just look at this graph. Look at this graph. By looking at this graph, tell me whether omega PC is higher than omega GC. It is very interesting topic, sir. Yes, yes. Right? It's very interesting. Really, I'm saying that we made it very interesting. I hope. Okay, nice. Now you see, by looking at this graph, don't look at any other thing. Tell me omega PC is higher or omega GC is higher. Because here also it's omega scale. Here also it's omega scale. You will start from 0 here. And it may be 1, 2, 3, 4. Maybe this is 4 and then it will become 5 here, 6 here, 7 here, 8 like this, right? Now, again 0, 1, 2, 3 and 4 here, 5 here for omega PC and then 6, 7, 8. Look at this, tell me whether omega PC is higher or omega GC is here. If you have minimum common sense, you will understand. Both are of the same scale. Omega PC is coming after omega GC. That means omega GC is coming before omega PC. That means omega GC as lower than omega PC, reverse way, or we can say like this, omega PC is greater than omega GC, right? Omega GC, then I am sure that the system is considered as, one second, I'm sorry, the system is considered as closed loop system is stable, correct? Closed loop control system is stable. Such a beautiful question this is, isn't it? Such a beautiful question. Closed loop control system is stable, right? So if you yes, it is stable, but still if you want to know how exactly it is stable, just I will ask a simple question to every one of you. Just see here, just see here. This is the way how we do from the Bode plot. Suppose at omega GC, draw a line here and look at what is the phase here. Okay, look at what is the phase here. So once again, look at what is the phase. This may be minus 160 degrees. Then what does it mean? At omega GC, the phase is minus 160 degrees. Then I can say that is actually called as a phi GC, which is equal to minus 160 degree. Straight away, phase margin can be calculated now. Phase margin is minus 180 degrees plus phi GC, I could say, that is equal to 180 degrees and minus 160 degrees. All the way this will be equal to minus 20 degrees. No doubt about this. This is easy to understand, right? And then what about gain margin here? This is phase margin is finished. To get gain margin, look at what is omega PC here. Just at omega PC means the frequency at which the phase is minus 180 degrees. Draw a line onto the magnitude plot here. Magnitude plot. Let's take this magnitude might be here, might be minus 20 dB here. Clear? Minus 20 dB here, right? That means I could say that 20 logarithmic of modulus of g of j omega PC into h of j omega pc, that is equal to minus 20 dB. Clear? Minus 20 dB. Now relax. From this, can I write like this? Modulus of j omega pc, h of j omega pc is how much? How much, guys? So 20 will get cancelled. So obviously you will be having 1 by 10, I guess. 1 by 10 here. So this is your modulus of j omega pc, h of j omega pc. Fine. But what is gain margin? Gain margin we know, which is called as kg, the gain margin, which is equal to 1 divided by modulus of g of j omega pc into h of j omega pc here. Right? So therefore I can say kg, which is called as a gain margin. Of course it is equal to 1 divided by 10 here. Obviously all the way it is equal to 10. That is gain margin, right? But in dB, if you want gain margin in dB, how do we do that? Gain margin in dB is 20 logarithmic of kg. Whatever the value we got here, that value should be taken 20 log. So 20 log of 10, fine, then it will be equal to 20 dB. Clear? 20 dB. What you understood here? What you understood? Whatever you calculated, whatever you have in dB scale, minus 20 means gain margin will become 20 dB. Clear? It's so simple. Just draw a line from here to here. If you see minus 20 dB, then plus 20 dB is the gain margin, because ultimately how much I need to add for this? I need to add gain margin to this such that the net value must be 0. So minus 20 dB plus 20 dB will become 0. So gain margin is equal to 20 dB. That's it. Simple. That's what we have calculated at the end. Clear? So with this, I have completed the concept of gain margin and phase margin. In fact, plots and frequency response analysis, all those things, that is what our primary topic. The only topic left is like a stability analysis from polar plot and stability analysis from Nyquist plot. Just give me 15 minutes of time, I will explain and I will complete this also. Please hold for some time. Okay, so just hold for some time. Now look at that. If you have polar plot like this, see, this is the polar plot. This is a simple polar plot. This is polar plot. Let me take like this. What we do generally is, when the polar plot cuts minus 180 degrees, clear? When the polar plot cuts minus 180 degrees, right? At that point, what do you mean by that? Polar plot cuts minus 180 degrees means, I would be saying omega is equal to, omega pc is there. Omega is equal to omega pc there. Correct? Frequency becomes phase crossover frequency. At that time, I will see what is the magnitude of this. Let me call the magnitude is L. So what is L here technically? L is nothing but modulus of g of j omega pc into h of j omega pc, because at omega pc only its magnitude. Then what is the gain margin? Simple. Gain margin is equal to 1 divided by L, or we can say 1 divided by modulus of g of j omega pc, h of j omega pc. That's all. This is so simple, right? So this is gain margin. So gain margin calculation must be like this from polar plot. How do we do the phase margin? If you want the phase margin, what is requested to be calculated first? If you want phase margin, you need to know the frequency at which the magnitude became 1. The frequency at which magnitude becomes 1. So for that, by keeping the center at this point, we draw the unit radius circle. When I draw the unit radius circle, that unit radius circle exactly hits at this point, the plot. What does it mean? This vector length is 1, because this is the radius of the circle here. This is the radius of the circle. Then I can say this is the frequency at which omega is equal to omega gc. At that particular intersection point of unit radius circle with the polar plot, I do calculate the phase from here to here, and that phase is actually nothing but phi gc. Clear? That phase is actually nothing but phi gc. And once I see the phi gc, then obviously phase margin is how much? Phase margin is equal to 180 degrees plus phi gc. That's all. This is the way how we do from the polar plot. Very easy and very interesting. Now, I have a question to every one of you. Think logically and tell me. We are changing from omega is equal to 0 and omega is equal to infinity. Correct? We are increasing the value of omega 0, omega 1 or 10, and we are increasing. When we are increasing, first we got omega gc here. After still increasing, later we got omega pc, correct? Later we got omega pc in the increasing. Tell me whether omega pc is higher or omega gc is higher. When you are going from omega 0 to infinity, first omega gc came, later omega pc came. So which is higher, omega pc or omega gc? Omega pc is higher or omega gc is higher? Any one of you? Omega pc is higher. Excellent, outstanding, right? Omega gc came first, means its value is lower than omega pc, correct? Because we are going from 0 to infinity. When you are going from 0 to infinity, after 0 1 will come, 2 3 4 5 6 7 8 9 10 11 20 100 30 30 100, like that it will go. So the value which comes first, that is lower than the value which comes later when you are in the increasing order, correct? So omega pc is higher than omega gc, or we can say both are correct only. I'm sorry, omega pc is higher than omega gc, then I could say that the closed loop system is stable. So that means even without calculating the gain margin and phase margin also, I can strictly say directly by looking at this, yes, the closed loop system is stable without calculating these things. Of course, if you calculate this, that is bonus additional things. Hope I have conveyed the message, and those who want so many questions to be solved on this, you can refer either rank up course and practice session. A lot of things are there available here and there. And last but not the least, which is very, very important concept, is how do we analyze the stability from the Nyquist plot? Okay, how do we analyze the stability from Nyquist plot? First of all, the very first step is consider open loop transfer function of closed loop system. This is very important. First, closed loop control system, right? That means G of s into H of s. Clear? G of s into, one second. Right. G of s into H of s. Just it will be completed in 5 to 10 minutes. So please be with me. Don't go here and there. So please be with me. G of s into H of s. And then construct Nyquist plot. Second step is going to be construct Nyquist plot. After constructing the Nyquist plot, then calculate number of anti-clockwise encirclements around -1, 0 point in complex plane. Complex plane, or we can say G of s into H of s plane. Fine. And then the number of encirclements, anti-clockwise encirclements. This is very important term. Anti-clockwise encirclement. So what if PP cut the unit circle more than one time? Good question. Polar plot cut more than unit circle more than one time. How is it possible? It means the more than one frequencies might be there for omega gc, right? So can you tell me one, Yeah. 1 second. Raghuram, wait. That guy is asking some question. Sir, what if polar plot cuts the unit radius circle more than one time? So if it is cutting more than one time, means there technically, mathematically, there are two frequencies where the function magnitude becomes 1. That's the meaning of that, right? We need to evaluate omega pc in that case to check whether the closed loop system is stable or unstable. At last, after that, the fourth step would be n is equal to p minus z, where p represents a number of open loop poles. Right side they explain. Right side of S plane, and Z represents number of closed loop system poles. Closed loop system, let me write down. Closed loop poles, otherwise. Closed loop poles in right side of S-plane. Right side of S-plane. Clear? So, if you know what is the value of n and if you calculate what is the value of z, if z is equal to 0, if z value is equal to 0, then it means that there is no pole of the closed loop system in the right side of S-plane. Closed loop system is stable. So, for the closed loop system to be stable, z value must be 0. And I will show you some example, then you will get a better idea about this. Just look at this. So these are phase crossover frequency. These questions I think you can manage. Let me take Nyquist plot questions. Okay, just look at this question, all of you. The open loop transfer function of a system has a pole in the right hand side of the S-plane. What does it mean? Open loop transfer function has a pole in the right side of the S-plane. Kya hai ye? What is the meaning of that? The meaning of the first line is P is equal to 0. Good. And the Nyquist plot makes one clockwise encirclement of -1 comma 0 point, J0 point. Okay, one second. -1 comma J0 point. What it means? One clockwise encirclement about that one. That means n is equal to -1. N is equal to -1. Right? N is equal to -1. Then they are asking whether the closed loop system is stable or marginally stable. What is this actually? This is simple question. So we know that n is equal to P minus Z. So he mentioned that one clockwise encirclement. As it is mentioned like one clockwise encirclement, I have taken n is equal to -1 because originally n must be n should be anti-clockwise, but he mentioned that is a clockwise. That's why I have taken this. Very good, Abhijit Bashir. Very good. N is equal to P minus Z. So -1 is equal to P value 0 minus Z. Obviously Z value will be equal to 1. So therefore Z is equal to 1. What does it mean? One pole. Z is equal to 1 means one pole of closed loop system lies in right hand side of S-plane. Right hand side of S-plane. So S-plane. One second. Right hand side of S-plane. So therefore I can say the closed loop system is unstable. Option A is the correct answer for this question. So yes, sir, pole is 1 for open loop. Yes, correct. Right. So ultimately the closed loop system is, oh, I'm sorry, Satyasri. Thank you very much. I think while I'm doing fast, I made the wrong answer. Just. Sorry. Extremely sorry, guys. Extremely sorry. Thank you, Satyasri. You are always there for me. Right? The open loop transfer function of a system has a pole. So it is 1. It is 1. So P is equal to 1 minus Z. So Z will be how much? This is going to be 2. Z will be equal to 2. That means 2 poles of closed loop system lies in the S-plane. The answer is not changing. That is unstable. Answer is unstable only. Okay. But the numbers what I have taken is slightly I done the mistake. Now she has corrected me. So thanks for that. So Z is equal to 2. The closed loop system is unstable. Now the most important point is, wait, I think I missed one question here. Yeah. Yes. Right. One question I will solve here. Fatafat. Just any one of you, what is the phase crossover frequency? Just let us take 5 minutes. Anyway, it is already 2:25. Let me take another 5 minutes and close the session. What is the phase crossover frequency for this? Guys, anyone? Phase crossover frequency. This is such a simple question here, right? So G of S is equal to this. That means G of J omega is going to be 1 divided by 1 plus J omega whole cube. So then phase of this could be written as the phase of this G of J omega. Of course, it is going to be minus tan inverse of omega, but 3 times because 3 poles are there. This must be equal to minus 180 degrees. Minus 180 degrees. And if you substitute omega PC, then what is omega PC? Tan inverse of omega PC is equal to how much? Omega PC is equal to how much? So it is going to be 60 degrees, right? 60 degrees. So omega PC is going to be equal to √3 radian per second. Simple question. This is √3 radian per second. Sir, can you prove the Can you prove the last Nyquist type 2 plot intersect minus 180 degrees? It can be either in the second quadrant. Why should intersect the second and quadrant? Vishwanath Murali, I think we need to discuss very elaborately regarding this. Okay, very elaborately. I think Are you student or you teacher? It's such a wonderful question you have asked. Like, I am admire of that. We'll do one thing. Let's connect separately and discuss that, because that it takes at least 20 minutes for me to explain that. Okay. So, but I love the question. I'm really love this question, because this question was asked to me almost in the year of 2015 by one of the student from from Kerala in offline center, and he entered to IIT Kanpur. Okay, so super question you asked, but I require a lot of time for that explanation. Please connect me, I'll explain that. Okay, so other guys, please note down that question, take a snapshot of that question and keep it with you. Okay, that I will explain that. So this is root 3, omega is equal to root 3. This is a simple question. Now, yes, this one, find the gain margin of open loop system, that is equal to G of S into H of S is equal to 1 divided by S into S plus 1. Guys, please take the question, snapshot of Vishwanathan Murali question. Okay, keep that with you. That's a fantastic question he asked. You also try, and those who try and get the answer for that, I can say you will be in top 100. Okay, you will be definitely in top 100 for that. G of S into H of S, that is equal to 1 divided by S into S plus 1. Any one of you, can you tell me fatapat for this? Replace S is equal to J omega, then G of J omega into H of J omega. Specifically, it will become 1 divided by J omega into 1 plus J omega. And if you want to calculate gain margin, first you need to know what is omega PC. Can anybody say what is omega PC value for this? So omega PC means the phase must be equal to minus 180 degrees. G of J omega PC, H of J omega PC, that is equals to minus 180 degrees. Right? So that means how it will be equal to minus 180. At what value of frequency it will become? Right? The phase must be equal to minus 90. So minus 90 degrees minus tan inverse of omega PC, this must be equal to minus 180 degrees. I think this is possible only at infinite frequency. Already we have seen this. Omega PC must be infinite radians per second. Omega PC is, please explain the Nyquist plot of open loop transfer function. I already explained, na? Abid Bashir, I have explained. Please check that. So I have already explained about the Nyquist plot of some transfer function, how to draw the Nyquist plot and all these things. So much time I took. So maybe I don't know whether you were there or not. I have explained that. Just give me 1 second. I missed the track here. So first let me complete this one. Omega PC is infinite radian per second. And now the gain margin. Okay, gain margin. If you want gain margin, then gain margin is equal to, sorry, let me take the magnitude at this part. First of all, magnitude of the system, modulus of G of J omega into H of J omega, that is equal to 1 divided by omega into under root of 1 plus omega square, 1 plus omega square. And if you want omega PC, then Kg, gain margin is equal to what? 1 divided by modulus of J omega PC, H of J omega PC. Of course, this will going to become what? Gain margin Kg is equal to omega PC into under root of 1 plus omega PC square. Now already you know omega PC is infinity, substitute infinity there, then you will going to get gain margin is equal to infinity dB here. That means this is absolute stable system. For any value of K, the closed loop system will become stable. So that's why gain margin is coming as infinity dB. I hope you understood this one. And coming to Abid Bashar, right? So he asked one question, sir, please explain the concept of Nyquist plot. Explain Nyquist plot of a open loop transfer function. That only I have explained. Okay, construction of Nyquist plot I have explained only for open loop transfer function only. The stability of closed loop transfer function can be found from the Nyquist plot of open loop transfer function. We don't have Nyquist plot separately for open loop transfer function and closed loop transfer function. Please mind this point. We have Nyquist plot construction only for open loop transfer function. From that, we will evaluate the stability of closed loop transfer function. Clear? So, Abid, I have explained that. If you still want, you can go back and see that concept. And I will give one simple thing, because I know being a student at student stage, you will be definitely having some issues with the Nyquist plot. Okay, you might be getting the answers. A lot of students are giving the answers. I really appreciate them, because many of the students who are there in the chat box, they are my previous students only, so they already know the way how I explained from the basic concepts. In case if any new student is there in the chat box or else in the live session, I sincerely request, even if you are getting the answers, at least after the GATE exam, it would be better before the GATE exam if you go to the Nyquist plot concepts. Otherwise, at least once in your engineering career, please watch this Nyquist plot lectures given by me. Okay, in recorded lectures, students have given the highest rating for that, so I suggest please go through that, so that you will be benefited maximum out of that. Getting answer and getting marks in the exam is different, but learning the concept is absolutely important. Okay, so the last question of the day, right, just let me see. The polar diagram of conditionally stable system of a open loop gain k is equal to 1 is shown in the figure. The open loop transfer function of the system is known to be stable. Excellent. I think this I have solved in the rank up course, but anyway, the open loop system is absolutely stable. What does it mean? P is equal to 0. The closed loop system is stable for what? The closed loop system is stable for what? Very good. So let me look at the options like this. Okay, P is 0. First of all, they have given P is equal to 0, and we know from the Nyquist stability criteria, n is equal to P minus Z, right? So P is equal to 0 now. So n is equal to minus Z. N is equal to minus Z. Now tell me when the closed loop system will become stable now. When the closed loop system will become stable. The closed loop system should be stable. The closed loop system will become stable only if Z value is equal to 0. That means you must get n is equal to 0. If you get n is equal to 0, then I can say the closed loop system is stable. Correct? So if n is equal to 0, automatically Z will become 0 because P is 0. So around minus 1 comma J0 point, you should not have any encirclements, anti-clockwise encirclements or clockwise encirclements. Number of anti-clockwise encirclements around the point minus 1 comma J0 should be 0. That is your final aim. But before going to the actual discussion, let me see the options and see I can eliminate something here or not. So first of all, look at that. Here they are saying that in this range, k is less than 1 by, see these two, right? 1 by 2 to 1 by 8. 1 by 2 to 1 by 8. What does it mean? K between 1 by 2 to 1 by 8. That is okay. 0.5 to 0.25. Is it correct first of all? Is it correct? So this range of k, this is the GATE previous year question. This shows that what? 1 by 2 to 1 by 8 means 0.25. 1 by 2 means 0.5, right? So I'm sorry. Right? 1 second. 0.5 less than k less than 0.25. Yes. 0.125. 1 by 8 is how much? 0.125, right? 1 second. Guys, 0.125. Right? So, do you feel that is there any kind of value of k which is more than 0.5 and less than 0.125? Because this option is saying like this. Is it correct mathematics or not? Look at this. Just apply your common sense. This was given in the GATE exam. Do you think that it is possible? K should be less than 0.125 and more than 0.5. Do you think that that is possible? It's absolutely not possible, right? K cannot be less than 0.125 and more than 0.5 simultaneously. Correct? This is not possible. This is the wrong way to give the option. So this is the wrong option naturally, right? So next, likewise you go ahead, right? So there is one more option like k should be this one, right? So k should be more than 0.5 and less than 5, and k should be less than 1.25. Now again, there is AND operation here. So it was saying that k should be less than 1.25 and k should be more than 0.5. How is it possible at a time? So see, k should be less than 0.125, k should be more than 0.5. This is also not possible. Correct? This is also not possible. Am I right? Funny question, right? So, and question is good question. Honestly speaking, question is good question, but the smart people can evaluate from the options also, right? So, I don't know why, maybe the professor who has designed the paper in that IIT, maybe they might not be so conscious about this one. Rarely that kind of mistakes happen, but we should catch that, right? So this one, look at this, k should be more than 5, and again this is AND operation. That is what a crazy point this is. AND means both should happen. Both should happen. K should be greater than 5. Okay, that means k should be greater than 5 and less than 0.125. This is also not possible. Correct, this is also not possible. Now last one, let's look at that. It's mentioned like k is greater than 1/8. Okay, and it should be less than 5. So last option is technically like this. Last option is technically, it should be like this, 1/8 and less than 5. Clear? So this is the last option meaning. So I think option D is a proper one. Option D, we can go with that, right? So out of all 4 options, option D is the only option which can give the answer here. Clear? So that's a beautiful way. So sometimes we need to use our brain properly. Okay. So otherwise, if you ask me how do we do this, sir, in the exam, if you don't get that idea, right? So my suggestion is, anyway, you know that this is wrong answer. So we will see whether this is correct or not. K is greater than 5, 1/8 and k is less than 5. In this particular range, let us take k value is equal to 2. Let's take k is equal to 2. Okay. So let's take example k is equal to 2. If you take k is equal to 10, if we take k is equal to 2, which is falling in the last range, So what can I say? This graph is drawn for k is equal to 1. Basically, this is drawn for k is equal to 1. So k is equal to 2 means every point will become twice. Every point will become twice. That means here when you say k is equal to 2 means this point will be multiplied by 2, this point will be multiplied by 2, this point will be multiplied by 2. So these are the 3 points here. Now this all the way, I would be appreciate the students if you can understand instantaneously. This graph is specifically for k is equal to 1. Clear? For k is equal to 1. It was mentioned in the question for k is equal to 1. Right? And for k is equal to 2, how the graph will be? Can you please see? And let me know. For example, for k is equal to 2, if I draw the graph, then I am very sure, again this will be like this, first of all. Like this, correct? So, but in this case, I'm sure that, okay, one second, this value is now, it is going to be minus 16, and this value here, it is minus 4, and this value is going to be minus 0.4, right? Now, be clear about this. This is a polar plot. It's not a Nyquist plot. It's simply polar plot because we don't have a closed contour here, correct? So, this is polar plot. Now, we should draw the mirror image of this. When you draw the mirror image of this, how it would become now, right? So look at that. This is the way how it will become. From here, it will going to be like this, Clear? So then, end of the mirror image should be connected to the starting of original graph like this in clockwise direction with the infinite radius. Then I am very sure this is the direction all the way. This is exactly considered as a direction. So I think I have connected the loop. Wonderful question, right? So excellent question this is. Now look at how many anti-clockwise encirclements are there around minus 1, 0. This point is minus 0.4. This point is minus 4. Minus 1, 0 might be somewhere here. Minus 1, 0 is somewhere here. So minus 1, 0 is inside that middle circle. Then if you want to calculate how many anti-clockwise encirclement, just draw a line like this. When you draw a line like this line, specifically if you see this line, obviously I can sense like this, right? So there is one encirclement, it's going in the anti-clockwise direction like this, one is going in the clockwise. That means this is clockwise encirclement for this. And this is going to make anti-clockwise. Clear? So therefore, one clockwise and one anti-clockwise, total number of encirclements are equal to 0. Total number of encirclements are 0. But we have already discussed that n is equal to p minus z. So n is equal to 0 and p is equal to 0 minus z. So then obviously z is equal to 0. Then the number of closed loop poles in the right hand side of the S plane is equal to 0. Then I can say the closed loop system is stable. Closed loop system is stable. So I hope I have conveyed the message. This is one of the fantastic question I have seen in the recent times. So option D is the correct answer. How many of you really enjoyed the class today? Please let me know in the comment section. Last question is really very good question, right? Guys, last question really, it's a very, very good question. I enjoyed a lot and I want to know from your side how many of you enjoyed this question. Please mention in the comment section. I really appreciate the students, all of you, for sitting with a great patience till now. It is almost around 3 hours, right? I have started the class almost 3 hours back. Just only 5 to 10 students only dipped. But I really appreciate the people who are with me up to now and enjoyed the session. And I wish once again all the best to everyone. In case if you have any doubts in any of the topics related to frequency response analysis and frequency plot, please do message me, and you can note down my Telegram channel at the rate Raghu. Please can you share the Telegram link here? Iron Guru 2022. So I learned a lot of new things today. Thank you very much, Raviteja. Thank you very much. Enjoyed a lot, sir. Thank you very much. Okay, so Raghu, I request you, please drop my Telegram link there in the chat box. Let other students who are very new to me, you can join and you can connect through the Telegram group. Whenever you get any question throughout your preparation, you can contact me. I'm very free-minded person. No hesitation from your side. You can happily contact me. I always help you. Okay. Once again, I wish all the best to each one of you. With the same momentum, you continue till the end. I'm very sure you will get success out of it. And I will be meeting you once again in measurement subject. If you are from electrical or instrumentation, then we will be meeting once again for the subject of measurement. And there is one more live session is about to come at 4 p.m. Don't miss that. Till then, take care. Bye-bye. Have your lunch and again come back to the 4 p.m. session. Thank you guys.